you want to finish all your 5 questions. That paper is as in, sometimes I set it intentionally where I want people to just poach for marks. I don't, well, it might be setting people to finish or to pass, but to use the tactic of poaching, you have to leave some questions out and you go to other questions. So sometimes it gets really hard for you to finish it, the mock paper specifically. Yeah, because I combine chapters and with heavy computation sometimes. You find in, let's have combined a question from rates of change with a question for correlation and regression. And then there are like 20 entries. Probably the exam sets you 12 entries. Yeah, they do that. That they do. So I just needed you to be poaching, not to try and finish. But people tried that and time caught you up. But I'll try to return your papers probably tomorrow. Okay. Guys, I hope you have graph papers or graph books. We did, someone reminded me to do a decision tree. I'll try to guide maybe at the end. I'll try to show some guidance. Okay, today is Thursday. And this is our revision class of, is it 13 or 14? Revision, let me see. Revision 13. So on Tuesday, you might graph. I don't know which graph you might do, but lately the examiner likes you to graph. It is Thursday, 21st. August. Okay, so let's start with a frequency curve and polygon. A frequency curve and polygon. Okay. This is drawn with frequencies against the midpoint. Against the midpoint. It is advisable. It is advisable. Oh, sorry, we should say these. These are because there are two. It is advisable that one indicates the class boundaries. The class boundaries on the graph. That one indicates the class boundaries on the graph. Okay. For the curve, for the frequency curve, we use a free hand. We use a free hand. Whereas for the polygon, we use straight lines to combine the points. What am I leaving out? Okay, so two classes, NB, to be an NB. Two classes are required. That is the lowest class whose frequency is 0, and the highest class whose frequency is equal to 0. Okay? So I tried to, I need to take this out. Sorry, I didn't see it. You need something? Hey, we haven't been with you. Were you online? Have you been online? Okay. We missed you. Okay, now, there are graphs that require two variables. The guy tells you to represent the two curves or graphs on the same, two curves or polygons on the same graph. So I'm going to start with that one. Then the other one might be an illustration. We may have to do two. I thought I'll do one and then the other one you try out. I'm going to do one which represents two, and then I'll give you one for you to try out. So let's go to March 2021. March 20. Do you have a question, Bar? Okay. March 2021. And then, okay. Yeah, March 2021 offers us something. Okay. Beautiful music. You hear it? That's Paul Cafero. That's my music. I love it. Oh yeah. You've listened. My favorite is Visidikirwa. You've listened to it. For you.com. Okay. My favorite is Visidikirwa. Ebyo byo birwa byama nange gyoli nze nkunyita kyama. Oh, sure. I can sing it for her. Yeah. Okay, so March 2021.
I have 900,000 for my department. The LPOs were
March
payment that was. Oh, my payment system by an email.
Kindly mute. This is for a frequency polygon. Yeah, so I want a curve. Guys, kindly mute. We can hear you this time. November 2023. Please mute. We can hear you. Let me try to get another question. We are going to come back to that. I want to treat a polygon differently. Or for us, we draw curves, but people will see polygon. Let me see. November 2023. They wanted the histogram here. Okay, they wanted the histogram. How do we do it? So we use this histogram and also estimate, because the histogram, yeah, we're going to draw a frequency curve and then use it to estimate the mode. Okay, these are polygons. I don't know why I picked all polygons. October 2021. Last year they needed us to draw a curve. Okay, no, it's all good. Let me see what they are talking about. Construct a frequency polygon. That was a polygon. I want one for a curve. Okay. Nonetheless, this is what we are going to do, guys. I'm going to use this example, then I'll go back to the one that I was telling you about for two polygons. Yeah, I've seen it. I've seen the May 2025. May 2025, they asked you for a frequency polygon, not a frequency curve. I want you to see the difference. Okay, so we are going to try out example. We are going to use it to estimate the mode. So example, our example is from November 2023, question 1C. Okay, so we are going to construct, that question is not there, but we are going to construct a frequency curve first for this data, and then we shall draw the histogram for it. Okay? Nice. So this is November. Guys, I hope you have the papers, November 2023. Looks like I don't have it. Oh, it's here. Okay, guys, here we are. Can someone read for us? Can someone read for us, please? Someone online. Okay, the table below shows a frequency distribution of wages per month of 100 employees of Kajara Tea Estates. So we have the salary, we have the number of employees. Using the information given in the table above, represent the data on a histogram and use it to estimate the mode. So for us, we are going to construct a frequency curve. Are you with me? Okay. So I'm imagining we all have the question. Now, okay, remember, the graph will have frequencies, and then down here are the midpoints or mid-mark. But we instead try to generate the boundaries. I suggest that you have boundaries. Now, when the examiner gives you such a question, don't try to draw his table. You don't redraw this table in the answer sheet. What you do are the values, the solution, because when you redraw the table, you are eating your time. Okay, so moving, we are going to use the boundaries of this. Now, there are two classes I've talked about. A class whose frequency is 0, the lowest class, and the highest class whose frequency is what? Is 0. Are you with me? The reason is simple. The curve must close. It closes. Okay, it's a polygon. This curve starts on the horizontal and closes on the horizontal as well, because it represents a histogram. A histogram comes off from this curve. You see that? And that's how a histogram is drawn. It's drawn from a frequency curve. Are you with me? Okay, so it should close. Now, the classes you need is this class and that one. Those you create yourself. Can you help me? What do you think is the first class here? Come again. Come again. The first class.
49.5.
49.5.
59.5.
What would be the first class there? With frequency 0.
Your person will cut that.
Oh, 0 to
I know, but it of course.
Come again. What do you
0
think would be the first class? What's the class with it? 10. So what do you think is the
10.
first class there? What was the previous
9.5.
class with frequency 0? Come again.
0 to 9.5.
Come again. Which class is before 50 to 59?
40 to 49.
42,
49.
49. There is a class here 40 to 49 whose frequency is 0. Then, what is the last class whose frequency is 0?
That guy is good.
140
140 to
to
149.
149. Are we clear? Now, from 40 to 49, there is nothing there. So we generate what we call a zigzag. What a zigzag does, it tells you that from 0 up to the first class boundary, there is nothing. Is that okay? So our boundaries, okay? Our boundaries here are going to be 39.5 to 49.5. Then 49.5 to 59.5. Is that clear? Am I clear? We need boundaries for this. Okay? Okay. We need midpoints. We need midpoints. But it is advisable that you indicate the boundaries to enable you locate where the midpoint would be. Is that okay? I think for explanatory purposes, I need to redraw this table. Okay, so the table I'm going to draw, okay. So we have salary, but don't do this in the exam. Don't redraw the examiner's table because it doesn't give you a mark. You just got it from the question paper and you're putting it here. So what you may draw is one with boundaries, probably. Yeah, but even then he waits on the graph because that's why he's going to award marks. Okay, so we have salaries. These are in limits. Okay, then we have salaries with boundary. This is for explanatory purposes. And then we have the F. Yes, sir. Okay, just a second. Let's first draw this. I'm going to pick it. Okay, so we said our first class, maybe the question might be related. Sir, I'm a bit late. Can I see where you started from? We just started. We just started right here. We just started. We had just had a bit of explanations that you may have missed, but that's where we are. You can take a screenshot. Okay, nice. I hope you did. Now, our first class with says 0, we just included it. I'll write it in a different color. We said it is 40 to 49, okay? Then his normal classes he gave are 50 to 59, 60 to 69, 70 to 79, 80 to 89, 90 to 99, 100 to 109, kindly mute, 110 to 119, 120 to 129, and then 130 to 139. Now, the other last class also, I'll include it in black to show you that we just generated it, okay? That class is 140 to 149. But do you know where I was? I was in Chitintare. So I left Chitintare at 4:50 to go and pick kids. And I had to connect for this class. I worried I would be late. In Rosita, yeah. You know where the Enterprise, is it Enterprise Uganda, where it is? Yeah, that's where I was. No. Actually, is where my grandparents are. I stay this side in Perero. Yeah. Your children started from around the bottom. That's why I had to pick them, and then take them. So I'm glad I made it in time. There wasn't so much jam because it had rained a little. I'm lucky. Okay, so guys, we translate them to boundaries. Okay, these classes. Whenever you are drawing a graph, limits never get to the graph. It's only boundaries and maybe past midpoints. Okay, you never take limits to the graph. Limits would go on a bar graph, graphs that are separated, that are not conjoined. Is that okay? Good. But boundaries are for the histogram. Okay. Okay, so this would be what? 39.5 to 49.5. Okay, then the rest can come in. This is 49.5 to 59.5, 59.5, 69. Guys, are you following?
Yes.
Guys online. Okay, nice. To 89.5. 89. Aunt Musiri said 99.
Nanti tukuwuliriza.
Oh, okay. Monsonyiwe nakula na jajja 9.5 and then 109. Yali anyumya nnyo 0.5.
Another Chris
Rest in
Evans.
peace. Annie, you people, you are speaking Luganda in a recording.
Omwo mwe tukwagalira.
I know you mean well. I know you mean well.
Yeah.
Tweyanziza 149.5. Okay, guys, here we go. A student temuwoneka. Zambale ndowooza n'Oluganda temulumanyi.
Tubaayo nga tulumanyi.
Mubeerayo. Okay. Omanyi ng'abantu bagenda kukola online exam, wali online exam. Naddala ba online students. Nsaba obaŋŋambire nti ekigezo kiri physical. They may get used to everything. Okay, guys, our first and last class, Mr. Baz, first scroll up. Up to where? Up to where? I would like to know. Where we started or where? Before that? Okay. Sam a bit late. Mr. Sir, take a screenshot. Can I take a screenshot as well? Okay, here you go. Here you go.
Charged forward seeking revenge on Kaya, but outside the station, the men from both sides quickly separated them. Still, Sadat warned he would make them pay one day.
Okay, guys, sorry, I temporarily went off, but we are back here. Seen it? Okay, then here, the only challenge people are not talk mainly online. Never to survey into one. Okay, guys, we take the frequencies. I guess you're done. The first frequency we said would be 0. And then these ones are as they are. This is 10, 14, 18, 24, 12,
So the first
7.
one is 8.
Oh, pardon me.
8. You skipped 8.
Oh, yeah, you're right. Antivano, 0. 8, 10, 14, 18, 24, 12, 7, 5, 2, and 0. A 0 starts and a 0 closes. Okay, nice. So now let's start. On the horizontal, we said we plot we plot the frequencies against the midpoints, meaning the midpoints are on the horizontal. Are we clear? The midpoints should be on the horizontal. Okay, so how many classes do you have? How many classes do you have? They are 11. In totality, you counted the extra we added, the extra 2. Okay, and then how many centimeters do you have? No, the total number of centimeters on the horizontal. They are 19, right? 19, 17, or 18. 19. So remember, we have to do the 1 centimeter, 1 centimeter.
18.
You remember? When you do the 1 centimeter, 1 centimeter, 1 centimeter is taken off the horizontal and 1 centimeter is taken off the vertical. Is that okay? So you're going to have 18 centimeters. We said the graph should cover at least 50%. So if we have 18 centimeters, half of 18 is 9, right? And we have 11 classes, meaning we can have a centimeter per class. Is that clear? Okay, so that sounds good if it's clear. And here we go. I think I'll write this here. And then on the vertical, what's the highest we can go? Up to 24. And we have over 27, 26 centimeters. So we shall also use 1. Perfect. Okay. So it is 1 centimeter for 1. Remember, all diagrams are in pencil. Okay, all diagrams should be in pencil. There we go. Remember how we did the graphical method? That's the same. So you do 1 centimeter, 1 centimeter. Yeah, both for the vertical and the horizontal. There we go. You write the heading. You write, so you are ahead of us. What will they say? Guys, try to mute unless if you're asking. Okay, so on the horizontal, I'm going to do a zigzag. I'll do a zigzag of 1 centimeter, right? This line can shift. Okay, so for 1 centimeter, you do a zigzag to show that from where it starts up to your first class boundary, there is nothing. Okay, so this would be 39.5. And then the next is 49.5, 59.5, 69.5, 79.5, 89.5, 99.5, 109.5, 119.5, 129.5, and then the other class, which has mine Mine wouldn't fit, but yours will fit because mine are fewer. Sorry, brother. For vertical, it's 1 centimeter representing 1. Mine is stuck here. It's not big enough. 140, 139, and 140. Yeah. What am I gonna do? Zigzag. Okay, I just have to do this. Okay, 139.5. This here is 14. This is 39.5. This is 49.5. This is, I just want to get some space. This is 59.5. And then 69.5, 79.5, 89.5, 99.5, 109.5, 119.5, 129.5, 139.5, and 149.5. Okay, I did this first part for purposes of fitting it. Okay. And then on the vertical, it's 1 centimeter, 1 centimeter. So you just run it. Okay, so this is going up to 24. I can set 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then 26. Okay? Now, we need midpoint. The midpoint of our first class is right here. This first class here, its midpoint would be 44.5, right? That first class, 39.5 to 49.5, the midpoint is 44.5, right? Am I clear? Is it okay? Huh? Okay, you know how to compute frequency, you know to compute mean for grouped data. That midpoint you add and divide by 2. The X, they call it the mid value, midpoint. Oh, sorry, hope it doesn't break. No, it's all good. So you get the mid value. Sometimes we were calling it a class mark. Okay, we were calling it a class mark, or what was the other word? Midpoint. Class mark or midpoint. You've understood? That same one, the X. That's the one. Okay, sounds good. Guys, together. So for the first one, 39.5 to 49.5, that will be 0. So it will be on the horizontal line itself. That's where the midpoint is. The essence of this zigzag is to show you that from 0 up to the first class, there is nothing you need. Okay, that's the essence of the zigzag. It can go on a vertical, it can go on the horizontal. Okay, now we start. The class 50 to 59, which is 49.5 to 59.5, its midpoint is right here. Okay, but it goes up to what frequency? Eh? It goes up to what frequency?
8.
Up to 8. So we shall put 8 here. Okay? The next midpoint is this one. What's the frequency? 59.5 to 69.5. The midpoint is 64.5. The midpoint, which frequency do you have? 10. So we move up to 10 right here. And then 69.5, 79.5. What's the next frequency? The next frequency is what? 14. Yes, sir. You wanted a pattern. Go ahead. Yeah, frequency against midpoint. That is for a frequency curve or a frequency polygon. Okay? Right here. These are drawn with frequencies against that midpoint. So you look for the midpoint. The essence of the class boundaries is to locate the actual midpoint. When you don't have the class boundaries, you might misplace a midpoint. So the class boundary is telling you this is where the midpoint should fall. So please locate it. Okay, so you don't misplace it. Yeah. Oh, okay. Because you are using, I get what you mean. Remember, you are using one centimeter for a class. Okay. So your class, it's not hard. Your class is, let's say, 49.5 to 59.5. Okay. It's a class of 10 units. You get me? And you are saying 1 centimeter is representing 10 units. Is that clear? So in this 1 centimeter, I have 5 small squares. I don't know if you can see them. It means each one small square represents what? 2 units. So now I'm coming from 59.5 to 69.5. How much do I add to 59.5 to make 64.5? Because that will be the midpoint. How much do you add? I add 5, not so? I add 5 to 59.5 to make 64.5. Is that okay? That means to make 5, I need 2 small squares and a half. So we are going to be placing these points after 2 small squares and a half for each of them. That scaling is going to be the same for all. Did it make sense for you? Okay. Guys, is it okay? You asked a very good question. Is it okay? Okay, good. If it were 2 centimeters, it would be easier, much more easier. Okay. We want the class 79.5 to 89.5. How many units was it? What was the frequency?
18.
Okay. 18. So we move up to 18 here. Okay, and then next we move up to 24, right? Next is 12. Next is 7. My 7 is here. Guys online, I hope we are clear. Next is 5. My 5 would be here. Next is 2. My 2 would be here. Oh, damn it. Sorry. I made a mistake somewhere. This was supposed to be here. 1, 2. It was supposed to be here. 18. This was supposed to be here. 24. This was supposed to be here. Here. 14. No, 12.
Buzz, is your midpoint on a thick line?
Come again?
Your midpoint, is it on a thick line, like you're plotting on thick
No,
line?
mine is not a graph paper. Mine is a squared book.
Okay.
Okay, so yours is clear. Yours is better. Yours is not on a thick line.
Okay.
Yours is in between. Is it okay?
Yes, please.
Thank you. It's a good question. Yours should be on the in between those lines. Okay. Next was that was 12, then 7. 7 is here. Then after 7, we have a 5. After 5, we have a 2. Now, after 2, we go to a 0. This last class here that we included, remember we needed the 2 extra classes, a class with frequency 0 and a class with the lowest class with frequency 0 and the highest class with frequency 0. Those 2 we needed. So our graph can close. Okay, you are going to have a better graph because for mine, this is where I cheated the centimeters. Okay, so that I could fit the graph. So roughly, mine would look like this. You use a free hand for a curve. Okay, we use a free hand. Oh dear me. Let me start it from down here. Yours is going to look much more better. Come again, brother. Okay. What do you have? What's the midpoint? Remember the midpoint? I use the midpoint of this class. What is it? So it will be 1, 2, and then a half. So every after a half, you have the midpoint. That's the midpoint. All this should be midway. Don't put them on a thick line. It should be midway here. Also, this should be here. They are not exact. Know what I mean? Yeah.
We have 39.
Yeah, yeah. So its midpoint will go with frequencies there. Remember, we are plotting frequencies against the midpoints.
So just take this one.
Yeah, it is. It is. Its midpoint is frequency itself.
No, that's a free hand.
Eh?
Someone is supposed to put the roller between like this.
Okay. Right here. For the frequency curve, we use a free hand. Whereas for polygon, we use, so this is the frequency curve. Okay, nice. So guys, where I'm curving through, I have a challenge. Yours should be better than mine. Yours is going to come out smoother. Okay, so that's how it would look like. Please. Yeah, the frequency curve, we use a free hand. Frequency polygon, you use a straight line. We are going to try and superimpose, or we are going to, It's the same, it's the same. Yeah, when you look at this, we're gonna talk about it. Yeah, you are talking about limits and boundaries. Okay, so the graph uses boundaries. When you are given limits, you translate them to boundaries by deducting 0.5 and adding it on the upper. Where you have boundaries, you don't need to change. Take them as is. The midpoints directly. Yeah, yeah. So this is what I don't know. Oh, it was in my other class. You'll pardon me. When you, how do I tell I have limits? How do I tell I have boundaries? Because the examiner is smart. He'll do this. Okay, let's first see. Let's first categorize. Assume we have scores. And our scores are 40 to 50, 50 to 60, 60 to 80. Hope this is what you are talking about. 70 to 80, 80 to 90, 90 to 100. And then I have scores 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and so on. So by observation, you can tell you have limits or boundaries. The boundaries repeat. Boundaries are exclusive in nature. You either exclude the upper boundary or the lower boundary. So when you see something like this, where the previous upper value is the same as the next lower value, then you have boundaries. And so these are boundaries. Where the figures are different, you have limits. And this is where we do a plus or minus 0.5 when you're translating to the boundary. Is that clear? When do you do that? You do that when they have asked you for a median, when they have asked for a mode, when they have asked for quantiles. Someone asked for notes on, I just forgot. I think I just forgot, but I'm going to try and share them. Or if you could send your login details to Andrew to help you with the class, the actual classes, the recordings, he may help. You get a login and you log into the evening or weekend class. You check. Okay, for this weekend, you can go through measures of location, measures of dispatch. But I'll send you the PDFs. Okay, now when you are dealing with this, quantiles, we have quartiles, we have deciles, and percentiles. We are going to determine this from cumulative frequency polygons or curves, mainly the quantiles and the median. Okay, the mode is from a histogram. So you will use boundaries when you have these. When they ask you for mean, standard deviation, you don't need to. Whether they are boundaries or limits, it is the same. Is it clear? The class mark will be the same, yes. No, it's the same. Let me show you. Under mean, you need X, the mid mark. That's all you need. So if I have a class limit of 40 to 49, what is X? Yeah. Let's translate it to a boundary. It will be let's get the class mark. It's the same, right? You have the same. It will be 44.5. So there is no need. You just use the details as they are. So translate to a limit or a boundary when you have any of the other 3 or 4. Yeah. Come again? Yeah, that's possible. Oh, no, just a second. They have given you limits or boundaries? They have given you boundaries and they need a median. Oh, yeah, they do it. Yeah, just pick from it. And also, if they gave you limits, you don't translate the entire data set to boundaries. You just go for the median class. It's what you translate. So you don't need everything. The moment you're able to identify the median class, because you get it from the cumulative frequency, you are going to see that. You pick it from the cumulative frequencies, identify the median class. Once you have it, it's the only one you translate, because they need the lower class boundary. This one here is all they need. Okay? Yeah. That's what? Yeah. I'm sorry. The way you get the chimbeja. Simanyi kyakola. Ate omumbejja bamusanvinga bafukamye. Kati tompa buzibu. Yeah. Or whether we are leaving 2 centimeters. You need to check the number of classes you have vis-a-vis the centimeters. On your horizontal, you have 18 centimeters left and you have 11 classes. So if you took a class for 2 centimeters, that means you need like 22 centimeters, which you don't have. So what you do, you take 1 centimeter for a class. So sometimes, like in that case, you need to know what the small square would represent for you to fit the midpoint. That's what we had to do. And you realize that if these are the small squares, Okay, we said to have the half, this is 1, 2, that is 4. And then each of them was representing 2. So to have 5, I go midway one of them. So you guys are placing most of your points midway the third small square. That's why it's supposed to be. Does it make sense? Yeah. So if you are unable to fit a scale, sometimes people do it manually. You write the figures to see if they fit. And then repeat and see. It's another way to do it. Only that you can not necessarily guess, you can easily fit. If I have 18, why would I use 2 centimeters? So 1 would be enough if I have 11 classes. Okay? Okay. I wanted to show you something here with the classes. I think I'll do it when I get there, because someone asked. So we have scores 40 to 50 and so on. So we have boundaries and limits. Now, there is when he'll present the data as 40. Baz was requesting for the title of the graph. Oh, sorry, pardon me. So we can say a graph, a frequency curve, a frequency curve of frequency against the mid-mark. Mid-mark or midpoint. Okay? Yes. Okay, so you're going to be tricked this way. The examiner knows that you think boundaries are always having a decimal. So he'll do this. Okay? Now, when people see this, they may feel he has given them limits. But just look for behavior. Okay? When you look at the behavior, this is 12 and this is also 12. So I have boundaries. I don't need to change them. Monfuna. The class width. Yeah. Boundaries. The class width you subtract and you don't add a thing. Okay, it's just a difference. For the limits, you subtract and add 1. The reason is simple. The limits includes the first and the last figure. Okay? Limits are inclusive in nature. Let me give you an example. If someone were in college from 89, 1990. For how long were they in college? Eh? Check again. Check again.
11.
For 2 years. You've said 1990 minus 1981 plus 1. Okay? Because 1990 minus 1989 is 1. Why do you say 2? Because 89 and 90 are included. They are part of the years he studied. So that's a limit. It includes both. A boundary excludes either of the two. It can exclude the lower or the upper boundary. Okay? And this is what I wanted to show you. Sorry, is this little classification clear? For a limit, we add a 1. A boundary, you don't add. You just subtract. And you're good. Yeah. Yeah. Do you know what we said? You first get the definition. Remember, the definition is the moment the upper boundary is similar to the next, then I have boundaries. The upper value of a previous class being the same as the lower value of the next, then I have boundaries. By observation, that's all you do. Is it clear? Okay. Yeah, sometimes I intend it. And I get back to answer some of the questions when I've done something. Because some questions are that's what they are doing. They are stealing the bean. So the coffee bean. Tag is the same as a general statement. This is not a question. He's telling us, sir, frequency curve is the same as frequency polygon. They are different in the sense that for the polygon, we use a free hand. Sorry, for the curve, we use a free hand. For the polygon, you use a rule, you use straight lines. Yeah. Olive, I hope that's clear. Okay. Polygon, we use straight lines. Okay. Good. What did I want to show you? Yeah, I wanted to show you something with classes again. This is what will happen to us. The guy will say 40 dash 50, 50 dash less than 60, 60 dash less than 70. Yeah, then I'm off. Oh, okay. Okay, so it gives you such classes, and then 70 dash less than 80. He's telling you that in this data set, he's excluding the upper boundary. Do you see that?
Yeah.
So when you are given a set of data and he's telling you to generate a frequency distribution, in your frequency distribution, as you generate it, if you have a 50 in the data set, that 50 goes to the next class. Because in the first class, it is excluded. He's saying you values are running from 40, but they are less than 50. So a 50 will go to the next class. Is it clear? Okay, sometimes he does this. He can represent it as 40 less or equal to x less than 50, where that x is the variable they are talking about. Okay, it is the same thing. That 40 less or equal to x less than 50 is the same way as writing this. It's the same. So standardization for that class is the 40 to 50. By default, they exclude the upper boundary. I hope I'm clear. When they write 40 to 50, 50 to 60, it's the upper boundary that is excluded. So that class is the same as this one, as well as same as this. I've written the same thing 3 times. Is it clear, guys? Okay. Then he may write 40 less than x less or equal to 50. 50 less than x less or equal to 60. 60 less than x less or equal to 70. Now here is excluding the lower boundaries. In other words, if I find a 50, I put it in the first class because 50 is excluded in the next. What does less than mean? What does less than mean? There you can say, look. Eh? Okay, let me explain. Is the red the one in a challenge? The one's in red. For instance, this one here, right? What that means that all values, that 40 is less than all the x values. So the x values cannot be 40. There should be a figure more than 40. But they should be equal or less to 50. They don't exceed 50. They are greater than 40, but they don't exceed 50. The next one here says They are all greater than 50, but they don't exceed 60. That's it. So if I had a 50, I record it in the first class, which is opposed to the first one. So you can write classes different. Okay, I don't know if it was 2023. I'll show you something. Yeah, Geno, right here, November 2017. Let me show you what we are talking about. So you see this? You see that? So he's looking at packaging and weights, the grams, okay? So when you look at this, he's telling you that 395 is less or equal to X, but less than 405. And then 405 is less or equal to X, less than 415. It means if I found 405, I don't put it in that class. I put it in the next. Here they're excluding the upper boundaries. And how do I get the class width? I just subtract. I don't add a figure. The reason is simple. One of them is excluded, and that is the upper boundary. I don't add it back. Is it okay? A boundary contains the limit. Are we clear? A boundary contains the limit. Some people are able to excuse people who confront them beyond their limits. But when you go beyond your boundaries, they will react. So they'll tell you, you know what? I'm cutting off this, you no longer have it. Or we are going to courts of law, depending, because you've exceeded the boundaries. Okay? So boundaries, limits are a subset of boundaries. Okay? That's why you cannot translate from a limit, from a boundary to a limit. You never do that. We only come from limits to boundaries. In those notes, it's explained, it's well explained. When I was talking about it, I'll just need a little reminder to send them to you. But let me just show you +1. Yeah, when we get to the scaling, usually the first graph, there are so many questions. Once we get to the scaling, would be good to go. Yeah, so, no, this is today. Anyway, I'll share probably at the end. I just wanted to show you the notes, but nice is it about Monday, Baba, no? The class notes we did. So you see here, we talked about the limits, the boundaries, and then also we defined what really happens. How do I translate? Okay, so they are clear. You get what you need for sure. I'll just make sure I share them probably tonight so people can read. Okay, let's keep moving. What did I want? So let's try, yeah, please. Yeah. No, you show him. Yeah, so you write it right below. You say 1 centimeter to represent 10 units. The 10 units is your class width. Okay? And then right here, you would say 1 centimeter to represent 1 unit. 1 unit of frequency. Okay? Yeah, because that's what you did. Okay, guys, that's said and done. I would like us to do the histogram. The histogram. Yes. Yeah. Eh? No, that's all. That's all. Usually, where he wants you to point out something, he may tell you to draw 2 polygons or 2 curves on the same graph, and then you comment the relationship. I'm going to show you something. Yeah, I'm going to show you something. Now, for the polygon, we will not do the polygon, but this is the polygon. We are going to just superimpose it here. You can use the same graph and we put the polygon. So we indicate that this is the curve. Then for the polygon, follow my red.
But what
Polygon,
about
I'll use straight line. Come again?
what about the mode?
We are coming to it. Let's just insert the polygon on this. The mode comes from a histogram. Man, simanyi oba mba confused nze naye. I'm going to try and get it organized. So now we are drawing the polygon, okay? So the polygon, insert it on the curve, okay? With a straight line. Yes, please. Yes. There's no? There's no what? Keep going. There is no? Okay, brother, they ask either. So what I'm saying is,
Please, are you hearing?
I think we went off.
Must be off.
Someone called him.
Okay.
okay, guys, sorry, I temporarily went off. Guys online? Okay, so if it were a curve, it's a freehand. A polygon, it's a straight line. So we're just pausing the polygon. Yeah. Because it's the same detail you need. Midpoints and the frequency. Now watch, sometimes they give you cumulative frequencies and they need to determine the mean or the median. Okay. Depends. Okay, so that will be the polygon. I'll put a blue on it. That's a frequency polygon. Okay, so the histogram. The histogram. Let me see if I can get it from here. Yeah, I'll use this October 2021 histogram and the mode. And the mode. So a histogram, we are saying this is a special kind of bar graph, where the bars are connected. Okay. It uses the class boundaries. It uses the class boundaries. It is drawn with the frequencies. Against the mid-mark. Okay, it is used to determine the model value. So how? Identify the tallest bar. That is bar with the highest frequency. Okay. And then join the vertices. Join the vertices, comma, diagonally of the model bar with the vertices of the classes below and above the model bar. Did someone call me? The model bar. Where the diagonal lines meet gives the model value. Okay. Take an example. We are going to use October.
The Kenyan girl.
Please, Grace, kindly mute.
So the bluntly. Next time you don't go with it, I know who I'm going to be far from because I don't want to clash. Never like VIP batching me, lucky.
Mixed Grace Nafuna, please mute.
I'm trying to remember and I want to know.
Just mute her.
Just describe.
No, she'll do it again. This you want. Grace Nafuna, please mute. Grace, please mute. Okay, it's just out of respect, please. Okay. Ngenda bateka wano. Chetugenda okukola
Crossing the boundary.
Nteekawo phone number ye. Ate njirina. Njiteekewo. Grace have never discussion medicine. Grace, kindly mute, please. Yeah, just respect for your colleagues. Okay. Guys, have you taken your ears for blowing? Have you ever taken them? That you'll do, you'll hear everything.
Ear slinging.
Everything. Where we pass loud. October 2021, question 1.
The best food.
Yeah.
The best food.
You've understood for sure. I hope kids don't hate school. Because when they see that stuff, they will think it never ends. October 2021. Anyway, about company cannot call the show standing. No, I'm only about classmates. Okay. So here we go. May someone read us? Guys, I think you can see questions that are asked, distinguish between bimodal. Now, one person responded. Those little questions I'm sharing, the little quizzes. Okay, distinguish between bimodal distribution and bivariate distribution. Giving an illustration in each. A variate is a variable. A variate, you can say a variate or a variable. It's the same. Bivariate, it's a distribution with two variables. Bimodal is a distribution with two modes. Multimodal, a distribution with several modes. Okay, it's the same. Okay. May someone read? Have I sent you data and data collection methods? I'll put it together and send. I'm just picking it from my notes anyway. Can someone read for us?
Okay, we'll read from B.
Yes, please.
The table below shows the cumulative frequency of time a patient has to wait in a queue before he or she can be called to see a doctor in a busy hospital. The table has waiting time in minutes and then number of patients cumulatively. So the question is, reconstruct a frequency table for the above data and present the data on a histogram, hence estimate the mode.
Okay, keep going.
Part 2, Roman number 2, calculate the variance of the above data. And lastly, using the relationship between mean, mode, and median, determine the median.
Yeah, so this relationship here, very quickly, you use the relationship of skewness. Remember? Skewness? Yeah? Pearson. So skewness is equal to mean minus mod, or into mean, nice, over standard deviation. So remember, you'll have these values. You'll have the mean. Here, the standard deviation cancels out, so you actually don't need it. You just need mean and the mode, then mean and the median. But remember, when you're computing, what would you be missing? You have the mode, you've already represented it, got it from there. What is remaining is the, yeah, that's it. You have the mode and the mean. In this table of variance, when you're computing variance, you have a column fx, or you have somewhere you computed x minus x bar. You already have the mean. You don't recompute it. These are just 2 marks. So don't do a lot of computation. He knows you have the mean from previous computations and the mode from the first computation. Okay, so it will be straight. You get what I mean? Is it clear, guys? Eh? Are you writing that? Yeah, you equate them. You equate them using skewness. That's what gives you the relationship. So the relationship is extracted. Mean minus mod is equal to 3 mean minus 3 median. Yeah. So this is what you use. He wants the median, make it the subject. So I'll take this to the left. So I have 3 median. Guys, pardon me if I'm fast, but I guess you have this. If you don't, I'll be sending it. It's in those notes I'll share with you. So 3 median is equal to 3 mean minus mean plus mod. So 3 median is equal to 2 mean plus mod. So you just punch in the figures you have. You have the mean, you have the mod. You'll divide that sum by 3 and you're good to go. Okay? Yeah, so. And fun enough, this guy puts for you these expressions down here. Eh? And that's why I told you that when you get in the exam, first read the formulas. Okay? First read the formulas. It should be here. Get what I mean? These two, they're right here. He gives them. So that's why you pick the relationship. So when you get the paper, total and questions, total and formulas to gain confidence. Okay, or to pick your rugs up. Okay. Okay, sounds good. Let's go back. I just wanted to do that little highlight. So we're going to reconstruct this. Now listen, we are lucky that is even mentioning this. You'll check in one of the exams, this guy did mention that. He gave people cumulative frequencies and he asked for mean and I guess coefficient of variation, most likely. So people didn't know that they were given cumulative frequencies. Okay? And that's why, once again, for each question, you start with the required. Then you try to go back in the phrase to see what the details the guy is talking about. What details he's talking about. Okay, I hope this is clear, guys. Eh? Okay, so let's reconstruct. To reconstruct, it's like he's helped you. When he tells you reconstruct, he has helped. But it's free to just say, given the cumulative frequency, construct a histogram. Okay, so a histogram, we use frequency, we use frequencies, or we use a frequency distribution. Okay, so let's go and redraw. Right here, we have We have the time. We have number of patients, cumulative frequency, and then the frequency. What is the cumulative frequency? What's a cumulative frequency, guys? A frequency that keeps on accumulating. It is cumulative, so it keeps on accumulating. Okay, that's a good one. But what did he give? Oh, okay. You would put here. Cumulative frequency does what? It keeps on accumulating. You're welcome. Okay. You wanted the frequency to come next. So start with details that have been given. Okay? Because that's what he gave. Okay, so we have 40, guys, remind me, I should see frequency density, okay? Remind me of that, because it relates to what we are doing. 59.5 to 69.5, 69.5 to 79.5, 79.5 to 89.5, 89.5 to 79.5. Oh, 99. Oh, dear me. To 99.5. 99.5 to 109.5. 109 to 119.5. 119.5 to 129.5. And then 129.5 to 139.5. Okay, so the values here he gave were 1, 3, 11, 29, 52, 73, 82, 88, 88, 97, 100. Okay, now we want the first frequency. What would it be? It would be 1. Okay, good. Next, it would be 2. Next.
11 minus 3.
11 minus 11 minus what?
11 minus 3.
11 minus 3. What do you get?
8. Wait.
8.
Okay. Is it 11 minus 2 or 11 minus 3?
11 minus 3.
It's 11 minus 3.
11 minus.
Okay, so this is the thing. This is the thing. The total number of figures that are less than 59.5, okay, was 1. Oh, sorry, was this one you see in red. Okay? Now, remember, to get this one, I'll show you. Let's see how it started. To get this one, there was a 0 here, whose cumulative frequency is 0. Okay? So this cumulative, okay, sorry. This, there was a frequency here. There was a frequency here. So this frequency plus the next frequency. If you had a frequency here and then cumulative. So this was 0 to have a 0 here. There is a figure which was here, to which this 0 was added to get a 1. To get this 1. It was a 1. Are you getting me? Now, there is a figure here which they add to the cumulative 1 to get the next figure, which is 3. Which figure did they add? They added a 2. Okay, meaning this cumulative figure, okay, minus the previous cumulative figure, you get the figure that is missing. Okay. This figure here, 3, minus the previous cumulative figure, you get the missing frequency. Is it okay? So to have the frequency here, okay, it would be the cumulative figure we have minus the previous. What do you get?
9.
We get
8.
8.
9. 11 minus.
Okay. And then 29 minus 11, what do you get?
18. 18.
Hmm? No, there is a 1
18.
here. This 11 entails the figures in that class, which are 8, plus the previous frequencies. Is it okay? So 29 minus 11 is what? 18. 52 minus 29. 20.
23.
73 minus 52.
21.
21.
15.
88 minus 73.
15. 9.
15. Then 97, you said 9 and then 3. Guys, have you understood? It is the cumulative frequency where you are minus the previous. You get the next frequency. Are we clear? Okay, perfect. Perfect. So now we are going to draw our histogram. Okay. The histogram uses, you may say it uses the upper class boundaries. That's what I would say, but we join the midpoint with the upper and lower class boundaries. That's what happens. Okay, like how I started it here is that it is drawn with frequencies against the mid-mark. So when you identify the mid-mark, you now join the mid-mark to the lower boundary and the upper boundary. That's what would happen. You're going to find some books telling you that you draw the frequency against the upper class boundary. But that is for cumulative frequency. Okay, because the cumulative frequency covers, it's a cumulative frequency refers to the total number of items that are below or above a given class limit or boundary. We're going to see it here. Okay. So let's move in. There are 2 classes we need. Okay. The class with frequency 0. Which class is that? The lowest class. 39.5 to 49.5. And the last class, which is 139.5 to 149.5. Its frequency is 0. Those are the two classes we need. So how many classes do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay? So I'm going to explain. For the first class, you are going to need the upper boundary. That class of frequency 0. You'll need the upper boundary. And then the last class, you're going to need the lower boundary. We are going to draw and you see it. The beauty is on your graphs, it fits. Okay, so on your graphs, you are writing all the classes. Okay, on mine, I'm going to eliminate one of them. But for illustration purpose, I'll try to show. Okay, it will come out. Okay, so you do 1 centimeter, 1 centimeter, the template. Guys online, are we at par? Guys online, are you there?
Yes.
Yeah.
Musili. Okay. Let us know when you are challenged. Okay, so here I go. You remember the 1 centimeter, 1 centimeter. Don't forget it. Okay, and then here we go. Okay, so you do a zigzag of 1 centimeter. Okay, that zigzag shows that from the start up to that class, the values were not needed. Okay, so from 0, look at this. From 0 up to 39.5, you don't need anything. But me, I'm going to indicate 49.5. Oh. Me, I'm going to indicate 49.5. You would do the same. The midpoint for the horizontal line for that class is at 0. It's seated at 0. So this is its upper boundary. Okay, which is going to connect with the class which has a frequency. It is a lower boundary of the starting class. So that's why you are free to start with the starting class. Do you get me? This starting class here can be taken out. Much take it there. No, you are not. The 49.5 is a lower boundary of the starting class. You need it. Yeah. So don't put 59.5. So it gives you leverage to skip that first class with frequency 0. Yet when you are drawing the curve or the polygon, you need that class. So that's why I wanted you to maintain it for consistency. Come again, the 39.5 to 49.5. So I wanted you to maintain that class. So for you, do a zigzag and start with 39.5 to 49.5 for better illustration and consistency. The scale is 1 centimeter to represent a class. So our class width is 10 for the horizontal. Okay? No, you're going to take up to, I think, 11 centimeters. You cannot use double because the double will take you up to like 22, but you have 18 centimeters. Come again? What do you mean two? One class. That's the thing we are talking about. So you need 22 meters. You first count the classes you have before you count the centimeters. Is it okay? Yeah, you have a query? Yeah, do it. It's okay. Yeah, same position. It is for illustration purposes. It is something I want to show you. In your exam, you will also be free to start with 49.5. If you don't do that, you won't see why I'm saying it. So you start with 39.5. When I illustrate, you'll see the need of starting from 49.5. Okay, you'll do the choice, whether you start with it or not. But I just want you to understand it. Yeah, so either way it fits. Okay, nice. So this is 59, oh, sorry, 59, 59.5, 69.5, 79.5, 99.5, 139, 139.5. Now, the other class 149.5 also indicate it. Okay? Yeah. The 139.5 to 149.5. When you see what happens, you choose to either always include it or to eliminate it. But it doesn't make sense for me to tell you eliminate it when you don't see what happens. That's what I want you to see. Okay. So for frequencies, what is the highest we can go? Come again. Come again. We can go up to 23. So it is 1 centimeter to represent a unit of frequency. Okay. So you do your thing. When you look at mine, you may do it differently. But for every 1 centimeter, you have a unit. Okay. Guys, this is my advice. Unless you're really very conversant with graphing, don't start with a graphing number. Okay? When you can, go into network analysis, go for correlation and regression, go for an index question. You can do a graphing question as your number 2. It means when you have settled into the paper. And this is a simple reason. When you make a mistake on a graph, remember it's your first question. When you make a mistake on it, it's really big. You need to redraw the entire graph and you're eating time. So you should have done a question that has given you rhythm into the exam. Okay? Questions that do that are hypothesis testing, questions of interpretation, questions of outline, or questions you feel you've practiced enough. Okay? But a graphing question is always after another number.
Buzzer question. I will take on it. I'll go back.
And look for a question in indices, hypothesis testing. Okay? It's common knowledge that you'll do a question on correlation and regression. Common knowledge, you'll have a question on indices. Yeah, so just make sure your practice is good.
There's a question here. Hello.
Yes, please.
Well,
Yeah.
if for example, I have a paper. Remember, we write each question at on a fresh page.
Yes.
So can I maybe if I've chosen question 5, but I know part B, C, and maybe D, and then can I first do those parts? Then another fact that I used another fresh pages. I can do on a different page.
That is common. Yeah. Let me tell you, I think I said it here before you did the mock. In the first 30 minutes, you're going to see someone asking for an answer sheet. Now, if you're one person who keeps looking around, you're going to be taken aback. You're like, number 3. He's planning his work. He's poaching. Then he'll come back and fill the blanks. That's what people do. Otherwise, the examiner comes to collect sheets and he leaves you with answers to your best question. That's what he's saying. So people do what you do in accounting. They fill the structure. They fit in figures they can see. Some people do that. The only thing here, you need to have a straight mind. Ojaku use figures at number 3, number 4. You'll mislabel the question number. And when you do that, it is the examiner's discretion to say, I think he was answering question 2. But people mark different questions. He may be marking number 4, the other is marking number 5. The guy marking number 4, yeah, I could take guide, number 4. Now, when he sees something different, he'll be like, guys, who is marking number 1? I think someone mismarked the question number. Now, that one you are at his mercy. Because when you send me question 4, meant for number 1, I mean, the more papers I mark, the more the money. The guy just crosses 3, says, no, this is not number 1. He gets another page. Yeah, so you have to be keen. Yeah. Right. No, leave a gap. Your number has to be together. It should flow. I've seen it where in one of the mock I marked, a student did number 2, then he brought question 3, part C at number 2. You don't do that. You don't do that. Yeah, it should be together. Okay, guys, we're closing. We're closing. For every 1 centimeter on the vertical, it's a frequency. Okay, so I can say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24 up here. Okay, now, guys who indicated that class 39.5 to 49.5, look for the midpoint. That midpoint is going to be on the horizontal line. Are you getting me? That midpoint will be on the horizontal line. Meaning, there is nothing you are going to draw. That bar for that class is on the horizontal line. And it goes up to 49.5. That's why that class is not needed. Its bar runs on the horizontal line. You see that first class you drew, 39.5 to 49.5. Its frequency is 0. So the bar graph or the histogram for it will run from 39.5 to 49.5 on the horizontal line. Let me illustrate it here. You have 39.5 to 49.5. The line will, the midpoint, let's say, is this. When I join the upper and the lower boundary, they'll join on this line. So that's why that class is eliminated when you are drawing a histogram. You literally start with the lower boundary of the classes they gave you when you're drawing a histogram. So that's the reason I excluded it. But now it is vivid even for you that actually you don't need that class. So when you do your zigzag, start with the lower boundary of the given class in the table. But for the frequency curve of polygon, you need it. That's where the curve starts. The midpoint that there is, if this is the midpoint of that class, that's where my curve starts. I hope I'm clear. For the curve, you need the class. For the polygon, you don't need it, and the reason is simple. For the histogram, you need a bar. That bar is on the horizontal line. It's not seen anywhere. It's until it gets to 49.5 that we start to see frequencies. Is it clear? Okay, sounds good. Okay, now 49.5 to 59.5. What's the frequency? 1. So we look for 1. My 1 is here. 59.5. Okay, just not to waste the time. I just want to illustrate midpoints, how you link them up, and then we shall just do the paths. Okay, 59.5 to 69.5, the midpoint is 64.5, and it goes up to a frequency of 2. So midpoint up to 2. So this is what I want to illustrate. Yes. That's the thing. I want to okay, that is for the ogive. The ogive or the cumulative frequency curve uses upper boundary or lower boundary, where we talk about the less than and more than graph. We shall see it here. So for a frequency, anything dealing with the frequency curve, it is midpoint. And this is the reason you're going to see it here. So when I get here, I join the midpoint to the upper boundary and lower boundary to make a bar. Okay, I need a bigger bar here. 69.5, 79.5 is 8. I'll use this one. I'll use it up to here. Okay, so look at this. We shall come to this and join. This midpoint of 49.5 and 59.5 is this. And then I join. Okay? Then for 59.5, 69.5, the midpoint was 64.5. We join it here. So you join the upper and lower boundaries to the midpoint. But the graph is not necessarily against the upper boundaries. No, not necessarily. That's why the confusion is picked. But literally, you get the midpoint of that class and you connect it to the upper boundary and the lower boundary. That's an illustration I wanted to do. But otherwise, you start to look for the frequencies and the boundaries. Okay? Look at this one. The one for 8, we are joining this. The upper boundary is this one. The lower boundary was this. Seen it? So that's where the confusion is, that actually people end up concluding that you plot frequency against upper boundary, which is not true. You plot the frequency against the midpoint, and then you connect the midpoint with the upper and the lower boundaries. Okay? That's nice. Okay, our next frequency is what? 18, right? So we go up to 18. So here you can freely draw. You can freely draw, at least you've understood what we are talking about. So 18. Okay, then the other thing is, guys, the illusion of this one was set, they cannot set it again. Should get out of your mind. The examiner is free to do what they want. Okay? Yeah, he checks performance against the question and it was not well attempted. He's free to put it back. Okay, then next is 23. 23 is up here. Please, once again, all graphs are in pencil. All graphs should be in pencil. Okay. And then next we have 21. 21, which is here. Then 15. Then 9. Then 3. Now, you remember that last class again? 149.5. You realize it starts from 139.5 to 149.5. Its midpoint is right here. But when you look at this, it's going to move on the line to connect to the other one. So you also don't need the last class. Is it clear?
Yes.
Come again? The class, this class here, you see that last class there, 139.5 to 149.5. You don't need it for a histogram. Is it okay? You don't need it. Okay? Why I told you to indicate them, I needed you to see that as you draw along, you won't need them. Okay? That was the major reason, brother. So this class you won't need the 149.5, and that's it. Okay. Now let's get the mode, because they told us to determine the mode from our graph. The model bar is that one, okay? The tallest bar or the highest bar. The tallest bar. We shall connect its vertices internally. They don't go out. Connect the left to the right, okay, of the previous class, like that. And then also left to the right. Okay, and then where they meet gives us the median. Sorry, gives us the mode. So we shall draw a straight line to come through here. Right there. This is the mode. What do you get? 90? He has 97.5. Is it okay? What do you guys have? So our mode is equal to 97.5.
But pardon, on the mode again, my network had gone off.
Oh, okay. Do you see how we joined the the vertices?
Yes, I see.
So where they meet, you draw a straight line down to the horizontal line.
Oh.
Okay. So halfway here, for me, that's a 5. So it is 80, sorry, 90, 94.5. You said 97, add on 3. 97.5. Perfect. Okay? They have the same. What else do we need from this? I think that's all. That's all. Frequency curve, frequency polygon, and histogram. That's it. Okay. We go to a cumulative frequency curve. So these are going to be easier because you know how to get the scale. Okay. Yeah. Yeah, you need to know. Okay, that's a good question. That what if the line is not necessarily on the line you've drawn where they met is midway a smaller square. Remember the 5? So you must know to the lowest unit. That's what the scale helps you do. If I'm saying that 1 centimeter is representing 10 units, that means the 5 small squares are representing 10. So 1 small square represents 2. Are we together? So if I'm midway it, then that means a 1. The line of the smaller one. Yeah, you take a 1. You take half of it. You take half of it. You cannot be to exactitude. So you do a plus or minus 0.5 for that unit. Yeah, pretty much. Okay. Yeah, what is it called? Something I told you not so I shouldn't forget. The frequency density. 90. Frequency density. Sorry, brother. No, sorry. Frequency density. It's something I told you not to remind me. Okay, so this is the ratio. This is the ratio of the class frequency to the class mark. Sorry, to the class width. Pardon me. Okay. i.e. frequency density is equal to frequency over CW. So this guy may tell you to draw a curve. Sorry, to plot frequency densities against the frequencies, against the class marks. Now, in most cases, frequency densities are going to be in decimal. They may be a challenge for you to draw. What you do, you translate them into percentages. Multiply them by 100 so you can easily get a scale. Virtually, you'll be drawing percentages, but indicating decimals. Okay? It's going to happen somewhere. I'll try to show you. Where you just translate the values into percentage, but you're indicating decimals. Like for instance, 0.1, I'll be drawing 10. My scales will be using percentages. Okay, I'll have percentages of the frequency densities and then the class mark. To ease the drawing, the decimals become a challenge for you to plot. When you translate them into a percentage, it is with ease. Okay? So I just wanted you to see this. The drawing or the curve is the same. You'll do the same thing, but I needed you to see that. Okay. Quickly, before we go to a cumulative frequency curve, I need to show you something. March 2021. I need to show you something. Sorry that I'm done. I've moved away from frequency density. I wanted to show you the formula, and that's it. The rest is the same, like the frequency curve. Okay. You can indicate percentage frequency density. Yeah. If you don't do that, you can do it virtually. The virtual part I'm saying, on your paper, you can get a pencil. You put them in percentage. When you are done with the graph, you return them to decimal as they are. Okay? Yeah. The frequency density against the class mark. Yeah. Yeah. It's like a frequency curve. Yeah. Frequency curve or frequency polygon. What you have done, you've only translated. When do we use it? We use it when the class width are different. Okay? Where they are uneven class width. That's when you would use it. He will tell you construct a frequency density curve. Okay? So you'll find that some of the classes are uneven. Otherwise, it's a frequency curve. Yeah. Okay. Yeah, it happens. It can happen. So you do a frequency density. You are looking at the concentration of the items within a class. And so that's why it is frequency divided by the class width. Yeah. Density. Okay, this is March 2021. I'm sorry, breaks are rare when I'm graphing. Yeah, because when we come back, I don't know where we stop. Unless we are going to switch between a graph, then we shall have a short break. Okay. This is what I wanted to show you. You see this? So the guy gives you a data set, and you are going to represent two variables. You remember what he talked about, the bivariate distributions. So this is a bivariate distribution. You have two variables using the same detail. Is that clear? So the question is age 20 dash, 25 dash, and then 60 dash. What are those figures? What should be here? And someone is saying 24. It could even be 25. So what do you go with? Why 25? Why 25? 25. Because it's what?
Because it's a class boundary.
How do I get class boundary?
To get the midpoint.
It will be easy to get a midpoint, I think.
No, you can't tell. You can't tell from this. You don't know whether it is the same. Okay. Have you heard about discrete and continuous data? Discrete data is for countables. Continuous data is for measurables. So what you do, you come and check the data set. What were they looking at? Can it be expressed in decimal? If it can, then those are boundaries. If you can't, then they are limits. Are we together? So what were they looking at?
Age.
Age. Can I have age in decimal?
No.
Can't I say I'm 63 and a half years?
As?
Yes.
Is it okay?
Yeah, you can.
Yeah,
It is
you
possible.
can have age as a decimal. He's 62.2 years. It's just that we rarely do it, but you can. Okay?
Have.
Come again?
You can have your years in fractions.
In fraction. Okay? And whenever you do that, you are creating an infinite number. Okay? Someone can express their age in microseconds. That's infinite. In milliseconds, that's infinite. So this was up to 25 because of the nature of the data set. Is that okay? Just do this. Am I able to have this variable as a decimal? If I can't, there are limits. If you can, there are boundaries. Okay, because you might say, now, is it discrete? Is it continuous? That might disturb you. You ask yourself, can I have this variable? If they're talking about number of cars, can I have 1.5 cars? No. Then these are limits. Now, so you go up to 24. That's the easiest way than going into the definitions. And that's it. Yeah. Limits. Yeah. Guys, in the notes I'm going to share with you, we did an example when we had a limit, when we had a boundary. So you will see when we are determining the mode, when determining the median. I tried to keep switching. Where the data set were limits, then I put boundaries, you know. So you'll see what it is. Yeah. Okay, so what happens here? I'm just going to illustrate. Here you are drawing a frequency curve. The guy is telling you, sorry, polygon. Draw frequency polygons on the same graph to compare the distributions of the teachers in school A and B. Usually, or sometimes, it can even ask you for a comment on the distribution or on the spread. Okay? Yeah, here you go. Comment on your results. Okay, so this is how it would look like. I'm just going to illustrate it here. Please, it's an illustration. It's not to scale. Now, you realize for age, the starting class, age of school B, the starting class has a frequency 0. Meaning, for school A, you need a starting class with frequency 0. Mufuna. Is it clear? Francis Chichikole, Woli Wetuli. Okay, let's get on the graph. How many classes do we have here? There are 9. Okay, so on our graph, we need 2 extra classes. We need a class for A that has frequency 0. Because the polygon for A must start on the horizontal. Okay, so this is, guys, we are ending this class at around 10, actually 10:15, just to prepare you. Okay, 10:15. Okay, so the first class for A here, which would be the first class for both? This is 20, so it would be 15 to 20. That's when A will have a 0. When you come to the last class, A had a 0, but B doesn't. So you create it. Am I clear? This will be, this goes up to 65, right?
I thought
So shall
the
have
first
60.
class would be 10.
Come again?
I thought the first class would be 10 to 20.
You see, our class width is 5. So you need to be cognizant of that.
Oh, okay.
Yeah.
Noted.
Okay. Guys, never rewrite this
Francis.
table.
Hello?
On your answer sheet, that table shouldn't be there at all. Even if you included the extra classes, You don't need that table. He will see the extra classes on your graph. So the examiner tricks you. He pulls you into redoing where he's not going to score you. So people redraw these tables on their answer sheets. You don't do that unless you are going to put cumulative frequencies, and it's going to give you a mark.
Hello.
Okay. Yes, please.
Hello, Francis.
Yes, please.
Why are you adding another class down, 65 to 70? I don't know
It's
the reason. Hello? Hello?
Maybe his network is not stable.
I just got off. Yeah, but the temple. Yeah. I was answering a query from online. Hello, guys, we are back. You are the temple leader.
Buzz, we had lost you.
Okay. I connected. Just a second. There's an improvement here. Let's do this. Let's do it quickly. Nena ntibarekedde ne mukikola. Ntibarekedde ne mukikola. March. It's March 2021. Okay, we do this one, guys. March 2021. And that is question 1. Okay, I'm assuming you all have it. Okay. So we have age. We have school A. And then school B. Okay, I'm going to leave blanks for this. So 20 dash, 25 dash, 30 dash, 35 dash, 40 dash, 45 dash, 50 dash, 55 dash, and then 60 dash. I've left a blank in the first line just to illustrate it, and a blank in the last. So this is 4, 6, 11, 14, 9, 5, 3, and 0. Then this one starts with 0. Oh, sorry. 0, 2, 4, 7, 11, 12, 11, 8, and 5. Okay, so this is the thing, guys. There is a first class for A. A should start at 0. There should be a class with frequency 0 for A. So that class is going to be 15 to 20 because our class width is 5. B already has, so on that same class, this is 0 for B. Am I clear? Okay, when we come down here, A already has a 0 for the last class, meaning B also needs a 0 here where it ends. Okay, so we need the class 65 to 70. Okay, so our classes are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so here we go. This would be zeros. A frequency, okay, maybe this will help you. When I'm drawing a frequency polygon, I have 10 here, I have a 20 here, a 30, a 40, a 50. When I'm drawing the curve, there is no when the curve will start from a hanging position. That's what you should know. It shouldn't start from a given frequency and then I go that like that. No. The curve must start at a 0 mark. Okay? It starts at the initial, there is an initial count. Like if you're looking at number of students that attended, there are those who didn't attend, where we start our count. Are we clear? Okay? So there is a number of zero frequency. We are looking at students who earned 1,000 shillings. How many did not earn that amount? Yeah, so we always have that figure. Okay, we're moving. Okay, same scale as before, only that here we have a frequency of 14. 14 is the highest, right? That means we cannot use double because on the vertical we have up to 27 or 26. I cannot use 2 centimeters for a unit. So it will still be the same scale. Okay, so okay. So I'll do my zigzag. And then start with that class of 15. 15, 20, 25, 30. I'll put 25 here. 30, 35, 40, 50. God, I got up to 70. Yeah, the midpoint will be this one. This is 65. And then 70. Okay. I've tried to manipulate one of them. Then on the vertical, we go up to 14. Don't forget. So this is 2, 4, 6, 8, 10, 12, 14. Could I have taken 2, 2? 1, 2, 3, 4, 5, 6, 7. Yeah, it would fit. So this is 1, 2, 4, 5, 6, 7, 8, 9, 11, 12, 14. Okay, so the first midpoint for 15 to 20 is right here. And that's where our curve will start from. Guys, I hope you are following. We are drawing for A. Then 20 to 25 is what? 4, right? So 4 is right here. 25 to 30 is 6, right? 25 to 30 is 6. Remember, you are using midpoints, okay? Midpoints and the frequencies. 30 to 35 is
Excuse me,
11.
please.
Yes, please.
I think you're too fast on that part. I'm not understanding well.
What's the challenge, please?
You said at 15, there is that part of 0.
Yeah, the
The one
midpoint.
with the zigzag. Yes.
Yeah. Come again? Come again? The
That part
zigzag
before-
stops at 15.
Yes.
Uh-huh.
Then from 15, that's where I'm not understanding well. Maybe you're too fast.
No, I think I'm not. Okay, I might have been anyway, because I thought we had done it. But this is the thing. You see this class here?
Yes.
That class before it, we are saying we don't need any information from 0 up to 15. So we put a zigzag.
Yeah.
Are you with me?
Yeah.
So for A, that class's frequency is 0.
Yes.
When you look at this class, its midpoint is 17, is it? 0.5? Because that is 35.
Yeah.
So at that midpoint, the frequency is 0. This is the midpoint right here.
Between 20 and 20, rather between 15 and 20.
Perfect.
Yes.
Is it okay?
Yeah, it's now fine.
Okay, nice. Now oyagadde kuŋŋamba nti ndi first kyoyagadde okwogera.
Obadde ompisizaawo.
You're reminding me I need to step on a taxi. One time, I got into a taxi here. Never pisa when I didn't know if I was tired. I was from an afternoon class on a Sunday. I remember pretty well. Class ya was sawa 10:00. So I jumped onto a taxi. Never pisa unavira mweno. I don't know if you know Lutete. Lutete on Gayaza Road. I was supposed to have gotten off from Mbele. Never
Lutete.
So I got off from Lutete. Someone has said Wasumagira. Yeah, I was just like. So I wondered what happens to the students there. Okay, guys together. Okay, so 30 to 35. Midpoint is right here. It goes up to, oh, aren't we done with 30? It goes up to 14, right? 14 is right here. And then, that is what, 30 to 35? No, 35 to 40, right? 11 tetujinagiteekako tugitaddeko. Yeah, we did. Okay. Then 40 to 45. Guys, I hope you are following. There is a 45 here. That's what I'm talking about. Are you following? Aha. 40 to 45 is 9.
Francis,
Yes, please.
Francis, sorry
Yes, please.
to take you back, but then I'm a bit confused. Maybe it's because
Yeah.
I joined your classes a bit later. You guys have been discussing. So I'm saying you're estimating. Do I need to first get X? Is it also okay if I first get my X and then my X will help me establish the midpoint? I can plot it in the middle or just.
That's the thing. Yeah. What we said is you plot the frequency against the mid mark. That's what we said. So you are very right. You are plotting against the X.
Oh, so I don't need to even find the X. I can as well just estimate on the graph to avoid wasting time.
You don't need to find the X.
Okay.
Because that's one of the things that take your time. On the graph, the examiner sees the midpoint.
Okay.
Okay? Yeah. So you don't need to recompute. You save on time. Okay? And that's why on your heading you say a frequency polygon of frequency against midpoint. So this is very clear for him to pick. Okay? And where you've indicated even the class boundaries, he easily picked the midpoint. I hope I'm clear. Okay. So we go to 5 and 5, 40, 45 to 50, 5 and 5. This is 5, and this is also 5. Then 55 to 60 is 3. 55 to 60 is 3. Right there. And then 60 to 65 is a 0. He gave it himself. It comes here. Okay, so since we are done with 1, let's finish it up. We join up the points with a straight line because it's a polygon. Okay. So from that red point to the blue one. Bana mugende musome ku pie chart eyo tetujja gikola. Sina wano gundi protractor. I don't have a big protractor. Find some time and read about it. I know some of you don't have sets, but remember what I told you, that's a timing bomb. It will explode in an examination room one time. He has never asked about a pie chart. That day you'll ask that question. You saw people borrow sets. Yeah, so be mindful. They can ask you that question anytime. Okay, there we go. and then here. Okay, this one is for what? Is for school A. In the exam, to show it with different, illustrations, you can use a dots. Okay, you can have one bold and the other dotted. Then you give him a key. Okay, because you would see some people trying to use blue and black pens, or a blue pen and a pencil, which doesn't work. Okay, now we go for B. For B, he tells you the class 20 to 25 is frequency 0. So the midpoint is at 0. We come here, 20 to 25. This is its midpoint. Right here. For it was indicated. And then next is a 2. Next is a 2 right here. Next is a 7. Thank you, sir. 7 up here. Next is 11. Right here. Next, 12. Thank you. Right here. Next, 11. Comes back here. Nice. Next,
8.
8. Right here. Next,
5.
come again?
5.
5. Bye mugamba basomesa boogera fast naye munamwe mwogera fast kanawe sina kyempulidde. Then
0.
Then 0. So 0 is that last class for which it wasn't given, right? This one here. So our midpoint is right here. So we're going to join it up with straight lines also. Francis, tunakubayoko ku Gantt chart. We did a Gantt chart. Tunakubayoko ku control chart. Yes, we shall do one. I prepared something. Someone? And then we go all the way. Okay, so there you go. Now, when they want you to comment, they want you to comment about the spread, the difference, and you use these gaps. You see the gaps in the curves? There are big disparities between the two distributions, okay? The disparities in age are big. So you may, sorry? No, it's a play. It's a play. Yeah, it's a play. It's a play. Okay. So there is the age between the age of teachers. Yeah, the age distribution of teachers in the two schools has a big disparity. There are big disparities between the two age groups. Okay. due to the fact that when you look at the distribution, the gaps are big. Sorry, here I've tried to. There's a huge gap. There are huge gaps. Okay, in the distribution. It is still wide. Anyway, you wouldn't go into computation of coefficients like standard deviation and coefficient of variation. Here he wants you to observe. A close relationship would be one where they are really tight close. Something like that. Okay. So maybe you can say between 0 and which age? Between 0 years and 40 years, the ages are closely dispersed, but then after there is a big disparity because it goes on to increase, okay? After 40 years to 65, sorry, to 70. The age distribution is closely distributed, okay, between 0 to 40 years. You see, there's a small disparity, or a relatively small, yet it's still big. The comparison we are doing is the before and then after 40 years. You realize after 40 years, the gap increases, okay? But it's still a big gap, even before. So it's a relatively small disparity between 0 to 40 years, but the age distribution depends from 40 years to 65, okay? Because of this disparity here. I need to remove these. Okay, guys, I want to move on to something. I don't know if there is any query. Okay, very briefly, November 2019. Guys online, are you there, please?
Loud and clear.
Okay, November 29. Okay, good. November 2019. Just to illustrate, we may not necessarily do it. It's a similar question. This one here. One of these people saw the other's paper. I don't know who saw the others. 2019, 2021. Okay, so here I just want to talk about the distribution. It's a two-way distribution. So how would you come up with your frequencies? So here you are looking at a sample of 150 married couples, the relationship between the age of a husband and the age of a what? A wife being investigated. So you will generate a frequency distribution, okay? You tabulate. So I'll have the age. You realize the age groups are the same. When you see age of wife, this is 10 to 19, 20 to 19, 29, then 70 to 79. Is that clear? Remember what we said about age, the question we just saw? Ours was continuous. When he came here, he's using discrete. So it is up to him. Here is the one who has given it. Even for number of cars, he can do the same thing. Okay, but where you need to tell, you ask yourself, can I have a decimal for this data set or not? Okay, that's what will predetermine your classes. You can have a decimal for the age because they are talking about ages of wives and husband. It can be a decimal, but from what the examiner has given, He has given you limits, not boundaries. Okay, this is the thing. When the examiner stipulates what he has given, go by that. Don't change it. But where there is a sense of ambiguity, then use the procedure if there is. Okay, use a standard if there is. You remember what I told you about time series? That for a time series, the period is the X standard. Unless otherwise he changed he has stipulated and tells you where X was the time series or where the cells, and then the quarters is the Y. In other words, he has to show it there. But where he hasn't, go by the standard. Your period is the X, and then the Y will be the time series you're observing. Yeah. Okay, so in this case, he was specific about himself. So quickly, we shall have the age, and then have frequency of wife, frequency of husband. Okay. The age is one because the categorization is the same. It's a two-way distribution. Okay, so we got a 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. They made a sort of a mistake here. This was supposed to be 50. 60 to 69, 70 to 79. Okay, you're going to help me. This you will do because he's asking us a similar question. It was the same. Frequency of Y, 10 to 19. What should I write? I should write? Someone is saying 8. Should I write 8 here?
That's 8.
Another one is saying 5.
8.
8. 8.
We write 8.
8.
Have you come to 8, guys?
5 plus 3.
5 plus 3.
5 plus 3. So for the age of the wives, the frequency, you do it horizontally. You go by that class. So this is a little interpretation. Wives aged between 10 to 19. Are we together? 5 of them had husbands aged between 10 to 19, and 3 of them had husbands aged between 20 to 29. Is that clear? Okay, let's go to the next one. 20 to 29. Wives aged between 20 to 29. One of them had a husband aged 10 to 19. 25 of them had husbands aged 20 to 29. Hope you get it. Okay. Let's go. So this would be 8. 20 to 29 will be
35.
35. 30 to 39 will be
36. 36.
36, you said?
36.
Okay. Okay, let's take it all. You seem to be very fast. 40 to 49?
That is 31.
31. Yes, please. Someone is asking.
I'm not understanding how you're getting the 8. I've seen you adding 5 plus 3, but why are you adding them?
Okay, this is the thing. Just listen to this explanation. Wives, these are the ages of the wives, okay? So wives aged 10 to 19, 5 of them, 5 who? The 5 wives, their husbands were aged 10 to 19.
Yes.
3 of them, 3 who? 3 wives had husbands aged 20 to 29. These numbers here are for the wives, the horizontal numbers. Okay, look at this one, 20 to 29. One wife had a husband aged 10 to 19. Mujye mulabe bano bali mu kuseka. Aha. No, but she was also, oh yeah, 20 to 29. Yeah, almost. Okay. Then you realize those who were in the same age group were many. So, wives aged 20 to 29, 25 of them had husbands aged 20 to 29. The lady that asked, does that make a bit of sense for you now?
Yes, so I'm supposed, like, for that class of 20 to 29, I would have to add all the, like, 1 plus 25 plus 7 plus 2, right?
Perfect. That's what gives you 35.
Okay, thank you.
Kati tuwe omu husband. Come to 10, to a husbands aged 10 to 19. Can you give us a frequency there? What would you say?
Husbands?
Yeah, these are the husbands. The husbands are here.
It would
And
be
these are their ages. What figure should we put here under frequency of husband?
10 to 19, it's 6.
6, perfect. 20 to 29.
Why is 6 not 5? I'm sorry.
21.
Come again. 20.
8.
28.
Oh, no,
21.
28, 29, 30. 30.
30.
It's 30.
Okay, there is a colleague we are leaving behind. She's asking about the 5 and 1. So, husbands aged 10 to 19. 5 of them had wives aged 10 to 19. One husband had a wife aged 20 to 29. Is it clear now, the lady that asked?
Yes, it's clear.
No.
Tukole ekyokubiri byonna tebisobola kugaana n'ekyokubiri bwe kigaana tukole ekyokusatu. Look at this. Look at this. Husbands aged 20 to 29. 3 of them, their wives were aged 10 to 19. Husbands aged 20 to 29. 25 of them had wives aged 20 to 29. And then a husband aged 20 to 29 had a wife aged 30 to 39. And then a husband aged 20 to 29 had a wife aged 40 to 49. Does it make sense now?
That one is okay, but putting them here.
Putting what?
Like how we 10 to 19, the frequency of husbands.
Yeah.
So I would
you add 5 plus 1, you get a 6. This 6 here. The 20 to 29, 3 plus 25 plus 1 plus 1, you get a 30.
Oh, they are all
Is it?
husbands, wives of different ages.
They are husbands of husbands who had wives of different age groups. Yeah,
Okay.
perfect.
Okay.
Yeah. Makes
Francis.
sense?
Hello.
Does it make sense?
Very much. Thank you.
Okay. You're
Excuse
welcome. Before you, there was someone that
Can I
was asking. Yeah.
Yes,
I wanted to ask something. Okay, my colleague, go ahead.
My question is,
Yeah.
what if I add a column and a row, then I put up all the total down there, like for
No.
5.
That would be okay. Oh, you want to add this, add that, then also add this?
Yeah.
That's what we are doing and filling in here.
Instead of coming up with a new graph, I mean a new table like that.
Oh, no. The examiner, this is part of your working. The examiner would like to see this table. Listen, guys. A figure that goes on the graph must either have been given as is, or you've generated and the examiner is able to see it. For instance, mid-mark. When I tell him a graph of frequency against a mid-mark, he's able to see a mid-mark on my graph. Now, when I go to the question paper and I add these figures and then go straight and draw the graph, the figures I'm putting like 8, 35, 36. The guy is not seeing them anywhere. He doesn't know where they are coming from. So he will think you are receiving support during the exam. So just make sure your figure has an originality. He can trace it. When I write 8, he won't say, I think he's meaning an 8 from the table I gave him, where he can't see it. So your figure must be traced. Brother, am I clear? Do I make myself clear? So this summary table should be there. The examiner marks it. He gives a mark to that. That's why these are 8 marks. Am I clear? So in the event you failed to graph, but you have this table, you may scoop for like 2 or 3 marks, because this is part of your working. Okay? Yeah. Now, that kind of procedure you were saying is very good. Actually, you do it on the question paper, and then now bring those summaries onto your answer sheet and show them. Okay? Is it fine, brother? Guys, you said this was 37. You said this would be 710. Is it 34? Go ahead. 24. Sure. Okay, we go with what you said. 13 and 6. Let's go for the wives. We are done 31, 21, 14, and then 5. Okay, now here is the thing. Here is the thing. You remember the 0, 0? Both of these need the 0, 0 class. So we shall have our class from what? Thank you. 0 to 9, you have a 0, a 0. And then this class is? Come again. 80, is it? Was 80 given? 82, 89. Now listen. Because he told you in a sample of married, they are 150, 150. Okay? So the total number of wives and the total number of husbands must be the same. No. He's talking of married couples. So it is rare that people marry at the same time. I don't know if you get me. They take. You are changing the script. I have a much of Actually, it's about wherever I wasn't counted from home because they never came home. So they used sample probably. Yeah, but what she's saying, the assumption here is it is one lady, one guy. That's the assumption. So when you add up, you cannot get a figure like 146 for one of the figures. You know you have a challenge if that happens. Okay? So it should be 150, 150. Okay? For the analysis is going too far. The analysis is going too far. So this would be 150. Maybe, guys, one thing I would like to highlight here, the examiner may silently come here and ask you for maybe a coefficient of variation. Coefficient of variation is standard deviation over what? Over mean. Are we together? Times 100. My game challenge, or the challenge is on S, standard deviation of what? We have standard deviation of a population and standard deviation of a sample. Now you have to be keen. Sometimes you get so much engulfed that you lose it out. So you come to the data and check, is sample mentioned anywhere? Okay, things that involve standard deviation, be very careful. There is a wording that is used when he uses the word unbiased. The unbiased estimates for the data were, the moment they use unbiased, that's a sample. Is it clear? When he uses the word unbiased details for the data were, he used the sample. Why? Under simple random sampling, you pick people randomly. The selection is unbiased. So whenever there is a word unbiased, there has been a random selection. So they selected a sample. Now, there is a question I may send you. I keep forgetting the seating, but I'll try to look for it. They use the words, and you need to understand these formulas. Variance of a sample. S squared. For ungrouped data, it is summation x minus x bar squared over n minus 1. Or s squared is equal to summation summation of x squared divided by n minus 1 minus summation x squared over n into n minus 1. Okay, that is ungrouped data of a sample. Then for grouped, I told you, I don't know if it was in this class, just introduce F. Okay, and this n here will be summation F. Okay. Come again? Oh, sorry. I'm sorry. I think somehow I skipped you all. So these formulas here is for variance. Let me do this. Variance of a sample. Case 1, ungrouped data. Monsonyiwe Njikozechi, I've taken a sidewalk. So that's how it would look like. Okay, then case 2 is for grouped. Case 2, you just introduce an F, okay? S squared, but you'll see all these in those notes I'll be sharing. We can say summation F minus 1. Or S squared is equal to summation Fx squared over summation F minus 1. This squared divided by summation F. That summation F is N, is N. In those notes, these things are written, so you'll have a good. Yeah, so with this little background, we can do a cumulative frequency curve. Okay, so with this, we go to, was it August? Did I read you August 2014? The ogive, yeah. I need the ogive. It does so many things. You'll need it. Was it the one? Yeah, it's here. Sorry? Oh, yeah. No, I need to do all graphs. I need to do all graphs, just know. Okay, most of them, okay, if I should say, because when I say all of them, there are those you don't do. Okay, the ogive or cumulative, no, the cumulative frequency curve. Let's first write that, and then the other one is also its other special name. The cumulative frequency curve. So also called the ogive. We plot the cumulative frequency against the upper class against the upper or lower, this is two-way or lower boundary. And I'll explain, because we have two kinds. We have the more than and less than cumulative frequency curves, okay, which we shall do. Okay, we can say it is used to determine what can you use it for? Come again? Yeah, say it. The median. Thank you, sir. The median. What else? Quartiles. Thank you. Deciles and percentiles. Now, they may ask you for a cumulative frequency polygon. Whenever you hear the word polygon, you are using a straight line. The curve is a free hand. An ogive is a curve. So when he says construct an ogive, he has specified that he wants a cumulative frequency curve. Are we together? Okay? And it's what we use to determine this. We never use the polygon. For the polygon, we don't use it to determine that, because the polygon is more exact. Okay? Well, unless otherwise, but usually it's the curve, because they are estimates. Yeah. Okay, so we take our example from August. August example. August 2024. Give HR one more. Naye examiner ali akubuuzizaako ansa nga oyina kugimunyonnyola nga waali physically. He asked your question where you need physical explanation, physical presence. Such answers where students start with, for example, where it doesn't have the definition, it starts by an example. August 2020. It happens when they put you in his corner. Okay, so guys, here is the question. State 2 disadvantages associated with data collection using questionnaires in sampling. I told you, buli omu ajja kuwandiika. Distinguish, when I said that a student yabuuza, ng'awandiika ki? Okay, distinguish between the terms decile and percentile as used in data distribution. Okay, those you have. Please. Yeah. 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 Yeah, I pretty much get you. So at times the examiner goes by what's the right word? He goes by the surface meaning. Surface meaning, just for lack of a better word, is where a student tries to express the definition through the way they understand it. And that's where students use formulas, because here it's allowed. You ask me what is a mean, I write you the formula, I explain the characters. Mean is equal to, I write the formula, then I tell you what the characters are. That's a definition in this particular subject. So for a decile, if I can get a formula for a decile, I'll give it to you. I mean, that's what I would put. If I can exemplify, right? And I say, hence, the decile explained, I get a mark. Yeah, so the examiner is marking your understanding. What does it mean? Your own way, sometimes. Yeah. People were asked differentiate between a point estimator and a confidence interval. A point estimator and a confidence interval. A student did this. Okay. This is X and that is Y. He puts a point here. And he said where X to Y is the range of a confidence interval. And A is the point estimator. What would you do? Now, students are not writing mathematical proposals. They are not writing some thesis or project, mathematical project. You just want to appreciate the meaning of words. That one will get a mark, for sure. You know, ekyatuuka mu COVID, after COVID, ba examiner babagambanga banaye mu mark nga abantu babadde mu lockdown. Bakavaayo, be considerate. N'oluzungu luyinza okuba nga tetuteredde bulungi. Just take the general meaning. I was somewhere and I had those words, those instructions. And the guy was right. If you didn't understand stress, people were stressed during COVID and people were trying to study as well. So the exam, not necessarily being lenient, but understanding. So in this case, you go by what you call, what's the right word? Substance over the form. what is he trying to say? What is the student trying to explain? Yeah, gwe range togiraba. Gwe point togirabye. Yeah, so that you leave it to the examiner's discretion. You'll get a mark. So that's why sometimes when I'm giving my examples in class, I'm very keen, because I know a student will get stuck at different. So it has to be really within their practice. Njaleta example nga telling you know, off. So as you give an example, it has to fit within. Yeah, so you would. Okay, so guys, quickly, we are saying that it is a requirement that before any air flight by Katanga Airways, weights of passenger luggage are taken in kilograms and recorded for further analysis. The table below shows a sample of classified. Guys, watch, whenever it says a sample, the word sample can be hidden somewhere. So when you see compute variance, he may not say compute the sample variance. He may say compute the variance of the data. Ask yourself, was it a sample? I'm insisting on only variance because that's where the effect of -1 comes in. Now, this is the trick. He will tell you part A, compute the sample mean. Okay? Part B, compute the sample variance. Now he knows in variance you subtract a 1. He has tricked you by saying sample mean. So he would like to see you divide by n-1. Whether it's a sample mean or population mean, we never divide by -1. Are we clear? For it is over n all the time for the mean. Mean of a sample and mean of a population are computed the same way. Okay, hope you can remember that. Okay, so construct a cumulative frequency curve, not polygon, from the above data. Okay, quickly. It will be after this that you will have a short break, I think. Okay. Mukoye closing. Abali online basomera mu Luxury.
Tetunnakoowa.
Temubeteekako.
No picture.
And they are in Luxury. Oh, injury time, no Luxury. Okay. So guys, this is question 1. The good thing it is graphing. So question 1. So 1 second. Are these limits or boundaries? They are limits. So even the table of translation, you don't show it. You will show that you are using boundaries on your graph. So don't avoid the tables here for that matter. You go straight to your graph. Okay. So it is cumulative frequency against the upper class boundary or lower class boundary. I'm going to show you why. Okay. Okay. So here we go. For purposes of explaining, I may have to draw my table. No, but I don't need to. Templates. Okay. 20, I think I have 2. Let me write it horizontally. So I have the weights. Me, I'll have 2 for explanatory purposes. And then number of passengers. Oh, we need a cumulative frequency. So meaning he expects you to write it. He will mark you for that. Okay, let's do it. Yeah, we shall need it. We shall need it. So we have the weight, we have F, and then cumulative frequency. Nice. So we have 50 to 54. And by the way, right here is where you can change to boundaries. In that one table, because you were required to draw that table, right? So within that table, you can do the boundaries straight on without the original values. So I would say 49.5, 54.5. 54.5 to 59, then 59.5, 64.5, 64.5 to 69.5, 69.5 to 74.5, 74.5 to 79.5, 79.5 to 84.5, and then 84.5 to 89.5. If it really did exist. The last one, we may not necessarily need it. So this is 14, 16, 25, 40, 30, 15, and 10. This is 0. Give us the cumulative frequencies. Okay, yeah, maybe guys, we do that too. So this one is cumulative frequency less than. Cumulative frequency less than. The question is less than what? Are we together? Less than what? Less than the upper boundary. We're going to put another one here. Munachijukida. Chumla. Just leave a gap here. I'm going to illustrate that too. Okay, just leave a gap. Okay, so the normal one is the one for less than the upper boundary. Okay, so this would be 14. Oh, now I'm going to explain. That's why I've left only one. We have what we call a less than cumulative frequency curve and a more than cumulative frequency curve. Yeah, there are two kinds. Okay, now we are computing frequencies the normal way. Okay? Okay, so this is 30. This would be what? 55.
95.
95.
125. 140.
And then?
150.
150. Okay, perfect. Now listen. When they say less than, you remember we defined cumulative frequency as the total number of items that are below or above a given class limit or boundary. When you say less than, okay, less than the upper boundary, in the class 49.5 to 54.5, how many items are there? They are 10. Are we together? Sorry, 14. They are 14. They are 14. Oh, no. That is class width, a class breadth, the size of the class. That's different from the class frequency. How many items vis-a-vis how wide, how far can it stretch? Okay. So for the class 49, let me use, I need to use these very ones. For the class 49.5 to 54.5, there are 14 items in that class. Now, if you remember boundaries, what I was trying to explain earlier, when you find them written like that, without any restriction, it means the upper boundary is excluded. Is that okay? The upper boundary is not part of the data set. So this is what it means. Guys online, follow red. It means that all items from 49.5 but less than 54.5 in that class are 14. Remember, 54.5 is the upper boundary. So the total number of items less than 54, sorry, 50, is it 54? 54.5 are 14. Not the black 14, the blue one. They carry different meanings. Okay? The blue 14 starts from 0. The black 14 starts at 49.5. Okay, you're going to pick it this way. Let's go to the 30. When you go to the class 54.5 to 59.5, in that class there are 16 items. Are we together? So in the class 54.5 to 59.5, 16 items in that class, these 16 are all less than 59.5. Are we together? So the question is, if you were to consider the entire data set, how many items would be less than 59.5? The items would be 30. This is the thing. The 16 items are in the class 54.5 to 59.5. All those 16 are less than 59.5. But we had a prior class which is below that class, meaning all its items are less than 59.5. So that's why we add the 14 in the previous class plus the 16 in that very class, all to be less than 59.5. Is it clear? Simanyi bamutambulirako mu bus. In the bus, zino buses zitwala egayaza. When you are in the bus, there's a person here, a person here. Waliwo ono oba yaba yasoose okutuuka, I don't know. The person who sits at the end here is usually the first person in the bus. We don't know. Okay, so there are people seated here. The back. Okay, people are seated. The cumulative part of it, okay, you go passenger per passenger. So if we have a passenger here, those 4 passengers, okay, we assume that whoever is seated here probably is the one who came in the earliest. His timing is better than whoever will come in later. Is that okay? So if his timing is better than these 2, and yet these 2, their time is better than whoever came in later, it means this guy's time is better than everyone's time. So that's the thing, that if 54 to 49.5 has 16 items, less than 59.5, it means if there are any classes below that class, all their items must be less than the upper boundary of that class. That's what it really is. So that's why we say less than the upper boundary. And it is normally what we do. It is the normal cumulative frequency. Okay? The one that's a bit different is the more. We are going to talk about it. Okay?
Francis.
Good. So let's draw. Yes, please.
So you mean when we're drawing now, this time around we consider the lower class boundary on the
No. Thank you for that. You are going to be plotting the cumulative frequency against the upper class boundary. Okay? Upper class boundary is for cumulative frequency, not frequency curves. Frequency curves, we use midpoints. And if it's an ogive, it's still a midpoint, but you connect the lower boundary to the upper boundary through the midpoint. So you can have a bar. Okay, very good question. Okay, so on the horizontal, guys, for the cumulative frequency, it also starts on the horizontal. It never hangs. It never hangs. But in most cases, when people draw, they have it hanging. This is the little thing. When you are drawing it, you need the first class with cumulative frequency 0. For it, that's all you need. You don't need the last class. For it, you need the first class with cumulative frequency 0. Then you'll take its upper class boundary. Now, this is the thing. The upper class boundary of that class is the lower boundary of the starting class. So you find yourself not needing it, but just need that little explanation. If you don't indicate it, you're going to have a hanging graph. So that's why I would need us to have it. So we shall need that class right here. That class of 40, is it 45.5 to 49.5? Okay, we shall need it. Okay. This is a bit disturbing. I'm going to show you why. 1, 2, 3, 4, 5, 6, 7, 8. 8, and then the other first class.
But is it for 44 or 45? 44.5.
Oh, 44. Pardon me, my bad. 44.5. Okay. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. We can use 2 centimeters to represent a class in this case. Okay? Because we have 9 classes and they are 18 centimeters. Come again, brother? 1 second. 1 second. Yeah, you do 1 centimeter, 1 centimeter. Just a second, just a second. Please practice the graphing. Just in case it is there, it should find you ready. Within 4 days. No, just know that next week, Thursday should come to pass. Yeah. You can't postpone it. Okay, and you guys will make it. Oh yeah, you will. You will for sure. You've put in your time, so. Yes, please. Yeah.
But it's
No.
Tuesday, Thursday.
Come again?
It's Tuesday, not Thursday.
No, I was just saying that next week we shall also have a Thursday. That's all I said. And it's nice actually to tell people, thank you, that's a good one, that the exam is on Tuesday. Maybe we're at Gamba morning. And by agenda for afternoon.
I was thinking next week by 1.
No.
And I was actually thinking they've postponed to Thursday.
No, dear. It's nice to read together. So this is 69.5. Guys, for you can use 2 centimeters for each class. It would. Oh, because you have a zigzag. The 1 centimeter. Yeah, so do one. Do one. No, it still respects something. 84. It won't be small. Okay, guys on the vertical, what's the highest you can go? We can go up to 150. Give me the scale. 1 centimeter to represent what?
20.
1 centimeter to represent 20. You might utilize only like 7. Esther is saying 1 centimeter to represent 25. It's going to be a short graph if you did that. Why don't you want to say 1 centimeter to represent 10? Yeah.
Yeah, to represent
1
10.
centimeter to represent 10. Okay. So for every 1 centimeter, we have 10. So I got a 10, a 20, a 30, 40. 40, 50, 60, 70, 80, 90, 100, 10, 20, yeah, 2 feet. So this is 130, 140. You said it goes up to 150? Oh, dear me. Okay, I'll put 150 right here. Horizontal, it's 1 centimeter to represent 10. To represent 5, sorry, 5 units. 5, the size of your class. It represents the class width. Yeah. You show the classes. Yeah, you do. You see, the lower ones become upper on the other side. When you look at 44.5 is a lower boundary of our first class, but it's an upper of the class with a 0. Our first class is what? No. 54.5 is an upper class boundary of our first class, but it's a lower boundary for the second, even when we were writing it out here. You see it? Yeah, so they are both upper and lower boundaries. Go ahead. Yeah, 1 centimeter represents 10. But on the other side, whenever you are failed with a scale, try to use multiples of 5 and 10. You physically write, you literally write on your paper that if I did 10, 20, 30, 40, how does it turn out? Do I have all my figures? No, let me try 20. So you can literally have what you need, okay, when you try it out. Okay, Good, good. So our first class is the class with a 0. Okay? Its upper class boundary is what? Come again. 49.5. Its frequency is 0. So right here. I'm just trying to show you some things you may not need. So right here. What does it mean then for a cumulative frequency curve? It means I need the first class, but the first class given can start, but its lower boundary is the upper boundary of a class whose frequency is 0. So this is what I wanted to show you. Oh dear, my battery is running. This is what I wanted to show you, that the class 44.5 to 49.5 is not necessarily needed. I wanted you to see it. Okay? All I need is its upper class boundary. When I'm plotting the first point that is not in the table they have given me, is a 49.50. That lower boundary of the given class right here is an upper boundary of a class whose frequency is 0. Is it clear, guys? Okay, so that class you'd literally not show it. So when you do the zigzag is going to come all the way up to 49.5. So that means you leave 1 centimeter and start with 49.5. Where I'm having 44.5, I should be having 49.5 with my zigzag of 1 centimeter. So my graph can start with the first class, lower class boundary. But you make sure that 0 is taken note of. Okay? It's one of those things that disturb. Okay, good. Oh, dear me. Yeah. I missed out a what? A 30? 34?
74.5.
74.5. Thank you. Munaye mwe muli wakanti 74.5. 79.5. Okay, is that all? And then 84.5. Guys, we start. This graph disturbs mainly for the start, and that's what makes it hang. The starting point makes it hang. Okay, what is our first cumulative frequency? Our first cumulative frequency
14.
is 14. That 14 is going to go with 54.5. What people do, they place it with 49.5. 49.5 is an upper boundary of our first class, which is 0. Are we clear? Okay, we begin. So this will go to 14.5. My 14.5 is around here. This is 15, so 14 should be here. Okay, guys, these are not midpoints, upper boundaries. Okay, 59.5 goes up to, is it up to 30? Okay, good. 64.5 goes up to? 55. So if this is 50, 55 is this one. Okay, then 69.5 goes up to? Come again? 95. My 95 is right here. And then 74.5 goes up to 125. My 125 is around here. And then next is 140 right here. And then lastly, 150 is right here. Okay, we join with a free hand. Okay, make sure a day prior to the exam you don't go out. Omukono gujja kankana. You don't go out. Ntinza bwe sinywamu sikola ki? Sewulira bulungi. Olupapula terutambula. We had guys at the university. A day before the paper, oh yeah. We had one particular guy, a friend of ours, so you can go and lead him. He was just smart. Anyway, guys, just make sure you sleep early. That's what I'm trying to tell you. Sleep early on a day before the exam. The bit of night shifts you read on the day prior to the exam, have enough sleep. If you don't, you will sleep in the exam. You get tired, the body gets tired. You are trying to give the same trend all through. So fatigue sets in on that day. I want you to do this. One time, go and present to people that are naturally day. You'll feel you dry up, you get stressed. So it's the same thing. When you are reading, I know you are doing marathon reading. When it comes to Monday, sleep early. You'd rather sleep early and wake up early. Not sleeping late and waking up like 1 hour to go to the examination room. Yeah, so try to rest enough. A day before the exam, feel free not even to read. Just hold discussions. Things where you just ask people. Okay, guys, we're going to use a free hand. If you can, you check the neighbor. So we join up here. It should be really a curve. Should be a curve. Oh, dear me. Okay, there comes mine. That's how it looks like. Maybe it's best I did this. It should be a curve, not necessarily straight lines. Don't try to make them so straight. It should be a curve. Okay, can we move in? Now let's use this curve to determine some things. Okay, so let's use to determine the median. Okay, the median, how do you get a median? Median. Using the graph. That's for the formula. So position of the median In the notes, I use this word. Position X is n out of what? N out of 2 for the median. What is our n? 150. Okay? So therefore, X will be 150 out of 2. And that is the 75th. Are we together? We come on our graph and look for where 75 is. So we shall come here, 75, right here. You draw a straight line, touch your curve, and then you come down right there. We got the 75. Do you have it? Did you compute? What compute is original? Then you need to know where it's coming from. Right here. You need to get the position of the median. But what day? Penna has 69.5. Do you also have 69.5? Because mine is less. 67? Okay, so mine I have, if that is midway of 5 would be 67.5. Yeah, plus or minus 0.5. Yeah, that's okay. So I have 67.5. Yes, please. That's okay. Within range, yeah. Those are within range. So our median will equal to 67.5 because that's what I have here. That's fine. You record what you have. You record what you have. No. It doesn't need to be the same in this case. Remember, you use the free hand. So your curving may differ, your sloping, but should be within plus or minus 0.5. Actually, sometimes they go as far as plus or minus 1. Yeah. Okay. Good. Let's get the third decile. Third decile. Third decile, the position. Thank you. Position X is 30 out of 100 times what? Times 150. What will it be? The 40 what? 45 or 45th. So we come and look for the 45th figure. Our 45 would be around here. 45 is around here. Okay, when people get to know graphing, they don't want to use the formulas anymore. Because from the graph you read directly. Yes, please.
Excuse me, Francis. Decile is out of 100 or out of 10? I thought it's supposed to be 3 out of 10 times 150.
It is the same. Deciles use equal percentages of 10. Okay, to split the data set. Yeah, you are right. It would still be the same. Because when you cancel this with that, you have 3 out of 10. But deciles use percentages of percentage intervals of 10. Okay, yeah. So what do you have? 65.5. So His D3 is 60. You said 60 what? 62.5. Okay. 62.5 and 63. They are all good because that's what I have. I'm sorry. Have you understood how to do this? Now, the guy will ask you, he may ask you to determine the Pearson's Boyle's. He may ask you for Boyle's quartile coefficient. People, if you are to go through the formulas to determine Boyle's quartile coefficient, it will take you a lot of time. It says you'll have Q at Q3 plus Q1 minus twice Q2 over Q3 minus Q1. So if you need to compute Q3, then Q1, then Q2, it eats up your time. So the best way to do it is use the graph. It will be smooth. Now, this is the challenge. People feel the formula is too long. So this is what they do. How do I get Q3? Oh, kindly guys mute. That's nice. You hear the girls? Eh? Those little voices. Mu weekend we tubeera tusoma owulira obunyonyi. When people are online, they show you wabayingiridde mu travel yaabwe naye tebagisazizza. Tebakola ebintu byombi. They study while off on a vacation. It's nice. In some classes, I tell people to do it, to show the video where they are, and they're in beautiful places. Someone forgot. N'alekawo naye omukono ogumu gwali gusipa olucupa. N'asaaliza abantu abali mu class yake. Asoma, and is also having the social life, the social beat. It's fun. Then the class never dated bidala. It's nice. Okay, guys, together, we have Q3. There is a way the examiner really insists on this. Q3 is 75%. Thank you, Esther. Okay, so Q3, the X will be 75% of 150. Okay, guys, what do you get? 1? 30? 1, 1, 2, 112.5. So this is 113. Are you with me? The 1 position. Now, what people do, okay, get us Q1, 25 out of 100 times 150. The X is 37.5. Okay, which is approximately the 38th. Give us Q2. Q2, we got it. It was 75th. No, Q2. The Q2 is the median. Q2 is the median, the 75th. Now, what people do, they get these figures and they're the ones they put in the formula. And the reasoning is simple. They feel they have written a very heavy formula. So the next computation is the figures we are going to get and put them in that formula. You don't put these figures in the formula. These are positions. So when I have the 113, 113th position, I come to the graph, look for it, get the figure. Have you understood? Okay. Now, quickly, we are going to do a graph for less than, and then we close. A graph for less than. Tomorrow, I'll use the first part of the class, and then the other class, I want to show you something to do with indices, where they have a missing figure. How do you go about it? Okay, that's the only thing I want to show you. But the notes I'll share with you, they have indices as well. Actually, the notes I'm going to share with you have measures of location, measures of dispersion, index numbers, and I think part of correlation and regression. So you go in and do the examples we did there. Okay. Now, come to this table and write cumulative frequency. Remember where I told you to leave a space. Cumulative frequency for, sorry, brother, for more than. So it is more than what? What about the graph for more than? It's what we are going to do. It is more than what? More than the lower boundary. Okay? It is more than the lower boundary. But you can submit out more late. Because some of your friends will be calling you, but your drink is getting what? It's getting warm. It's getting cold. Atengeli cold. Hiyo kibera wano ku Friday class. Yali esumbu once. When it gets at 9, friends start to call people. People were sitting in December. If you have to do it now. Because in December, November, engage with your associates. Okay, now listen. More than looks at the lower class boundary. Figures more than the lower class boundary. So now this is the thing. Let me remove this. This is 14, 16. Now, more than you look at the lower boundary. Let me ask you a question. How many items are more than 49.5? How many items would be more than 49.5? Because it's more than the upper.
14.
Okay? 14. Now, this is the thing. You would always want, okay, it is 14, and 14 are the ones in that class. Are we together? But a class 54.5 to 59.5 is above that class. Meaning the items 16 in that class are also more than 49.5.
Yeah, 150.
Even this last class, 79.5 to 849, has items. The items there are also more than 49.5.
Right.
So what do you think it is?
150.
Is that okay? So the
Yeah.
best way to do this, you add coming from down. You determine the cumulative frequency coming from down. Okay? So you would have, this would be 10. Thank you. Come again. 25, 45, 85.
This is 55, not 45.
Oh, which one? Oh, 55. Thank you. And then 90, 95, 11, 120, right?
Yes, 120.
120, 136, and 150. What we are talking about. Okay? Now, my question is, do you plot the graph against the upper or against the lower?
Lower.
Against the lower. Are we together? Because it is more than the lower class boundary. Okay, so I'm going to put a little summary here. Plot cumulative frequency against the lower class boundary. Okay, and then here, plot cumulative frequency against the upper class boundary. Okay, so 49.5 will go with 150. You come here, 49.5, look for 150. It will be here. And then 54.5 will be 136. 54.5 is 136. 59.5 will be 120. Guys, are you following? But you don't have any, you don't have, I don't feel any voice that is giving way. Tulinga abakatandika.
Tuli wano.
64.5, no, together. 64.5 is up to 95. We gotta go. Is up to 95. 95 is right here. And then 69.5 is against 55. 69.5 is against 55, right here. 74.5 is 25, then 10. 25, right here. And then 10. Now, you remember that last class of frequency 0? Its lower class boundary. There is a class here, 84.5 to 89.5. That would be last class here. This one here, of frequency 0. You remember it? Its cumulative frequency will be 0. Are we clear? So 89.5 is the upper, not so. We are interested in the lower. Its lower class boundary is 84.5. So we go here. Okay, so now we join. You are going to see something unique. We join. Okay, let's join. People funny. Okay, there we go. You see where it crosses? Somewhere here. yellow. You see that? That's the median. So the guy will tell you using a more than and less than cumulative frequency curves, determine the median. That's the table you will draw. Is it okay? Yeah, on the same graph. The two graphs come on the same graph. You can also use the more than cumulative to determine a median as a standalone. Halfway that graph still gives you the median. Okay? Nice. Guys, I beg we leave it at that. Tomorrow, the plan is to do the Lorentz curve and that Z, the Z chart. A Z chart is a time series graph. So we shall do a Z chart and a time series. I don't know if you've seen where the guy tells you compute the centered trend and then show the original data and the trend values on the same graph. So that we shall do after the Z chart.
Excuse me,
then,
sir.
I'm not sure if we can do a control chart. You've started control charts, you did them, right? Control charts are probabilistic charts. They are confidence interval charts. Okay, they are confidence interval charts.
Excuse me,
okay,
sir.
so unless otherwise,
Sir,
I should be able to plot those graphs.
clarification.
Then, draw a highlight. What time tomorrow? At 6. At 6, I have, the notes going to be shared. Yeah, let me share in the group. Let me share these notes.
Excuse me.
Oh, yes, sir. Go ahead.
Thank you for today. It's been very educative. I
appreciate.
I am just trying not to cram this more than and less than.
Yeah.
Now the more than, yes, I get that you use the lower class boundary, but kindly explain for me the cumulative frequency.
Oh, okay. For the more than graph,
yes,
it is best you draw, you get the cumulative frequencies coming from down. Okay? So if we were to come from down, I don't know, do you see my green pen? Are you able to see it?
Yeah, I see it.
Okay, nice. So the starting frequency is the 10 here. Now, to get the next one, it is this cumulative frequency of 10 plus 15 to have 25. The next is 25 plus the frequency of 30 to get 55. The way you get the other one for the less than, you do the same way but starting from below.
Yeah, I get that. So but when you were doing it, there's a way you explained it that more than, but you were explaining it from the point of the class.
Okay, it is more than the lower class boundary. Okay, more than the lower class boundary. When you look at the class, how many items are more than the lower class boundary? So when you look at 49.5, the entire data set is more than 49.5. That's the assumption. So that's why we take 150 to be the first cumulative value. If you want to get the next one, you can have 150 minus the frequency in that class to have 136.
Okay.
Is that okay?
It is okay. Thank you. Thank you very much.
Okay, you are welcome. Guys, I'm going to share some questions on indices. I may share like 2 or 3. Try them before our class tomorrow. Okay, yes. Yeah. No, you remove 14. 14 from 150, you get 136. Then remove remove 16 from 136, you get 120. You're welcome, Spanner. I appreciate. You get it? You use the frequencies. Don't use the cumulative. You use the frequency, because I guess you are using the cumulative frequency for the other. But use the frequencies of the classes.
Excuse me, sir.
Okay, guys, I'm going to share these notes here in our group. Yes,
Okay,
sir.
but
Yes.
I'm just asking, shall we have any session where we're only handling questions and answers, only that part?
On which part?
Like the whole paper. Like we get one paper
Oh, it's unfortunate. We were doing questions earlier, and I've been doing revision, I think, since July, where we're doing chapters. So they decided to give us a pro bono class. What I can do is to throw light.
It's okay, even if you just tell us what is about that number, how we are supposed to handle, that is fine, even if we don't handle the question.
Yeah, I know what you're talking about for sure. I know what you're talking about. I hope that time will be enough. Sir, you share the notes in the general group WhatsApp. Which one is that?
QT revision.
The revision. Yeah, let me share. I'm going to share. QT weekend. So guys, tomorrow I have a class. I have a normal class with the guys who are sitting in December. So I need to ask them if we can create more time. Their lecturer may come in my class and then we do this. Yeah, they may have accounting or FA. Oh, sorry, cost, I think, cost account. I've talked to their lecturer and then they communicate. I know it might be so early, so late. Okay, guys, either way, I'm going to share the notes and then tomorrow is going to be pumped up. Yes?
What I'm asking is, are you going to share them in the normal QT group, not the revision group, but then the normal one that has been going on?
Oh, okay.
Thank you.
Yeah, that's what I was
Some
also
of us just
asking,
have QT
because
revision,
some
so
of us
I
are
don't
not
know
in
whether
the QT revision group.
We're kindly requesting Obai shares in both.
In the group I keep posting, in case you are not in the group, I post some, definitions. What's the difference between this and that? They're like quizzes. So people share that in the morning, afternoon, and evening. Just definitions, no computations. Try to respond whenever you can. Okay? And when you see it, it's when you respond. Don't take time, you will not respond to them. Okay? You respond what you can. Okay? Yeah, because I know it's also part of the exam.
Francis,
Okay. Yes, please.
what I was asking, the clarity I want. You're going to share in
Yeah.
both the group of evening and then the revision.
Yeah, because I envisage some people are not in the revision group, so I should share in both.
Thank you.
Francis, the students may need your number.
Thank you, Baz.
Come again, sir?
The students may need your number.
My number. Oh, yeah.
Yes, your
Oh,
Airtel
yeah,
or
pretty
WhatsApp.
much. It's here. It's here. Guys, for the number you use MTN for queries. Use the MTN line, but calling you can call either of them. Yeah. You use the MTN for queries. 775-651-647. Yeah. Okay. People, if God allows, I should be able to share some like a highlight of the chapters. I just forgot to share it. So by tomorrow I should have shared it. That under measures of location, you should know this. Under measures of dispersion, you should know this. Okay, under time series, what should you be doing? Something like that. Okay. Yeah. If you don't have it, you can send a hi to Andrew. Andrew shared. Oh, send me a hi so you can be added to the group. Either way. Okay. So guys, have a good night and thanks for coming, please. Yeah. Guys online, thanks for attending my class. We meet then. We meet tomorrow at 6. You have a phone. Ah, okay.
Thank you, Francis.
Yes, sir.
Thank you so much, sir.
Oh, you are welcome, brother. Keep in touch. Keep in touch anyway.
Okay, sir.
Yeah. Hey, hello, brother. How are you? Good. You're welcome. I should bring your papers tomorrow. Yeah. Oh, with the guy. Hmm? Yeah. Oh, you tried it out? Yeah, it's the way to go. Where to go? It's practice. Okay, guys. Good night too. Take care. Good night, sir.